I don't know what it's like to be an alien. I would like to know.
Two alien civilizations coexisting on a planet. What's that look like exactly?
When you see them and they see you, you're assuming they have vision. They have the ability to construct in 3D and in time. There's a lot of assumptions we're making.
What human level intelligence has done is quite different. It's not just that we remember states that the universe has existed in before, it's that we can imagine ones that have never existed and we can actually make them come into existence.
So you can travel back in time sometimes.
Yes.
You travel forward in time to travel back.
Yes.
The following is a conversation with Sara Walker and Lee Cronin. They have each been on this podcast once before individually, and now for their second time, they're here together. Sara is an astrobiologist and theoretical physicist. Lee is a chemist and, if I may say so, the real-life manifestation of Rick from Rick and Morty. They both are interested in how life originates and develops, both life here on Earth and alien life, including intelligent alien civilizations out there in the cosmos. They are colleagues and friends who love to explore, disagree, and debate nuanced points about alien life. And so, we're calling this an alien debate. Very few questions to me are as fascinating as what do aliens look like? How do we recognize them? How do we talk to them? And how do we make sense of life here on Earth in the context of all possible life forms that are out there? Treating these questions with the seriousness and rigor they deserve is what I hope to do with this conversation and future ones like it. Our world is shrouded in mystery. We must first be humble to acknowledge this, and then be bold in diving in and trying to figure things out anyway. This is the Lex Fridman podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Sara Walker and Lee Cronin. First of all, welcome back, Sara. Welcome back, Lee. You guys, I'm a huge fan of yours. You're incredible people. I should say thank you to Sara for wearing really awesome boots. We'll probably overlay a picture later on, but why the hell didn't you dress up, Lee? No, I'm
This
just
is
kidding.
me dressed up.
You were saying that you're pink. Like
Yeah.
your thing is pink. My thing is black and white, the simplicity of it. Where's the pink? When did it hit you that pink is your color?
I became pink about, I don't know, actually, maybe 2017. Did you know me when you first?
I think I met you pre-pink.
Yeah. So about 2017, I think I just decided I was boring, and I needed to make a statement. And red was too bright, so I went pink, salmon pink.
Well, I think you were always pink. You just found yourself in 2017.
There's an amazing photo of him where there's like everybody in their black gown and he's just wearing the pink pants. It's
Oh,
on
that
the
was at the
internet
Wagon
somewhere.
and University
It's totally nuts.
100-year anniversary. They got me to give the plenary, and they didn't find an outfit for me, so they were all wearing these silly hats and these gowns, and there was me dressed up in pink, looking like a complete idiot.
We're definitely going to have to find that picture and overlay it. Big full screen, slow motion. All right, let's talk about aliens. We'll find places we disagree and places we agree. Life, intelligence, consciousness, universe, all of that. Let's start with a tweet from Neil deGrasse Tyson stating his skepticism about aliens wanting to visit Earth. Quote, "How egocentric of us to think that space aliens who have mastered interstellar travel across the galaxy would give, pardon the French, would give a shit about humans on Earth. So let me ask you, would aliens care about visiting Earth, observing, communicating with humans?" Let's take a perspective of aliens. Maybe Sara first. Are we interesting in the whole spectrum of life in the universe?
I'm completely biased, at least as far as I think right now we're the most interesting thing in the universe. So I would expect, based on the intrinsic curiosity that we have and how much I think that's deeply related to the physics of what we are, that other intelligent aliens would want to seek out examples of the phenomena they are to understand themselves better. And I think that's kind of a natural thing to want to do. And I don't think there's any kind of judgment on it being a lesser being or not. It's like saying you have nothing to learn by talking to a baby. You have lots to learn, probably more than you do talking to somebody that's 90. So, yeah, so I think they absolutely would.
So whatever the phenomena is that is human, there would be an inkling of the same kind of phenomenon within alien species, and they would be seeking that same.
I think there's got to be some features of us that are universal. And I think the ones that are most interesting, and I hope I live in an interesting universe, are the ones that are driven by our curiosity and the fact that our intelligence allows us to do things that the universe wouldn't be able to do without things like us existing.
We're going to define a lot of terms. One of them is interesting.
Yes.
That's a very interesting term to try to define. Lee, what do you think? Are humans interesting for aliens?
Well, let's take it from our perspective. We want to go find aliens as a species quite desperately. So if we put the shoe on the other foot, of course we're interesting. But I'm wondering, and assuming that we're at the right technological capability to go searching for aliens, then that's interesting. So what I mean is, if there needs to be a massive leap in technology that we don't have, how will aliens prioritize coming to Earth and other places? But I do think that they would come and find us because they'd want to find out about our culture, what things are universal. What about, I mean, I'm a chemist, so I'd say, well, is the chemistry universal, right? Are the creatures that we're going to find making all this commotion, are they made of the same stuff? What does their science look like? Are they off planet yet? I guess I think that Neil deGrasse Tyson is being slightly pessimistic and maybe trying to play the tune that the universe is vast and it's not worth them coming here. I don't think that, but I just worry that maybe we don't have the ability to talk to them. We don't have the universal translator. We don't have the right physics. But sure, they should come. We are interesting. I want to know if they exist. It would make it easier if they just came.
So again, I'm going to use your tweets like it's Shakespeare and analyze it. So Sara tweeted, thinking about aliens, thinking about aliens. So how much do you think aliens are thinking about other aliens, including humans? So you said we humans want to visit, like we're longing to connect with aliens. Why is that? Can you introspect that? Is that an obvious thing that we should be, like, what are we hoping to understand by meeting aliens? Exactly. Asking as an introvert, it's like I ask myself this all the time. Why go out on a Friday night to meet people? What are you hoping to
I think the
find?
curiosity. So when I saw Sara put that tweet, I think I answered it actually as well, which was, we are thinking about trying to make contact. So they almost certainly are. But maybe there's a number of classes. There are those aliens that have not yet made contact with other aliens like us. Those aliens have made contact with just one other alien, and maybe it's an anticlimax and slime, all right? And aliens that have made contact with not just one set of intelligent species, but several. That must be amazing, actually. Literally, there is some place in the universe, there must be one alien civilization that's not made contact with not one, but two other intelligent civilizations. So they must be thinking about it. There must be entire degree courses on aliens, thinking about aliens and cultural, universal cultural norms.
Do you think they will survive the meeting? And by the way, Lee did respond saying that's all the universe wants. So Sara said, thinking about aliens, thinking about aliens. Lee said, that's all the universe wants. And then Sara responded, cheeky universe we live in. So cheeky is a cheeky version of the word interesting, all of which we'll try to define mathematically.
Cheeky might be harder than interesting.
Because there's humor in that too.
Yes.
I think there's a mathematical definition of humor, but we'll talk about that in a bit.
Interesting.
Yeah, sure there is, yeah.
So if you're a graduate student alien looking at multiple alien civilizations, do you think they survive the encounters?
I think there's a tendency to anthropomorphize a lot of the discussions about alien life, which is a really big challenge. So usually when I'm trying to think about these problems, I don't try to think about us as humans, but us as an example of phenomena that exists in the universe that we have yet to explain. And it doesn't seem to be the case that if I think about the features I would argue are most universal about that phenomena, that there's any reason to think that a first encounter with another lineage or example of life would be antagonistic. I think, yeah, and I think there's this kind of assumption. I mean, going back to Neil deGrasse Tyson's quote, I mean, it kind of bothers me because I'm a physicist, so I know we have a lot of egos about how much we can describe the world, but that there's this like, because we understand fundamental physics so well, we understand alien life and we can kind of extrapolate. And I just think that we don't. And the quest there is really, really to understand something totally new about the universe. And that thing just happens to be us.
I agree. There's something else more profound. I think Neil is just he's just trying to stir the pot. I would say from a contingency point of view, I want to know how many ways does the universe build structures, build memories, right? And then I want to know if those memories can interact with each other. And if you have two different origins of life and then origins of intelligence, and then these things become conscious, surely you want to go and talk to them and figure out what commonalities you share. And it might be that we're just unable to conceive of what they're going to look like. They're just going to be completely different, infrastructure. But surely we'll want to go and find out a map. And surely curiosity is a property that evolution has made on Earth. And I can't see any reason that it won't happen elsewhere, because curiosity probably exists because we want to find innovations in the environment. We want to use that information to help our technology. And also curiosity is like planning for the future. Are they going to fight us? Are we going to be able to trade with them? So I think that Neil's just, I don't know, maybe, give a shit. That's really, I think that's really down on Earth, right?
How would aliens categorize humans, do you think?
How would we? So let's put it the other way around.
Slime category?
Maybe, no. Maybe we could, the thing is a bit odd, right? Look at Instagram, Twitter, all these people taking selfies. I mean, does the universe is the ultimate state of consciousness, thinking beings that take photographs of themselves and upload them to an internet with other thinking beings looking at each other's photos. So I think that they will be...
What's wrong with that?
I did not say there was anything wrong with it.
It's consciousness manifested at scale.
Yeah.
Selfies.
Yeah.
Instagram.
It's like the mirror test at scale.
Yeah. I do think that curiosity is really the driving force for why we have our technology, right? If we weren't curious, we wouldn't have got out, left the cave. So I think that Neil's got it completely wrong, in fact, actually. Of course, they'd want to come here. It doesn't mean they are coming here. We've seen evidence for that. I guess we can argue about that, right? But I think that I desperately, and I know that Sara does too, but I won't speak for you. You're here. I desperately want to have missions to look for life in the solar system right now. I want to map life over the solar system. And then I want to understand how we can go and find life as quickly as possible at the nearest stars, and also at the same time do it in the lab just to compensate, So sure.
Yeah, I just one more point on this. If you think about sort of what's driven the most like features of our own evolution as a species, you could and try to map that to alien species. I always think like optimism is what's going to get us furthest. And so I think a lot of people always think that it's like war and conflict is going to be the way that alien species will expand out into the cosmos. But if you just look at how we're doing it and how we talk about it, it's always our future in space is always built from narratives of optimism. And so it seems to me that if intelligence does get out in the universe, that it's going to be more optimism and curiosity driving it than war and conflict, because those things end up crushing you. So there might be some selective filter. Of course, this is me being an optimist. I'm a half full kind of person, but...
Is it obvious that curiosity... Not obvious, but what do you think? Is curiosity a more powerful force in the universe than violence and the will to power? So, because you said you framed curiosity as a way to also plan on how to avoid violence, which is an interesting framing of curiosity. But I could also argue that violence is a pretty productive way to operate in the world, which is like, that's one way to protect yourself. The best defense is offense.
I'm not qualified to answer this, but I'll have a go. I think let's not talk about violence.
That's the summary of this podcast.
Maybe I would. Let's not call it violence, but I call it erasure. So if you think about the way evolution works, or the way obviously talk about assembly theory, but I won't.
Yeah.
So if you say you build curiosity allows you to open up avenues, new graphs, right? So new features you can play. What the ability to erase those things allows you to start again and do some pruning. So the universe, I think curiosity gets you furthest. Curiosity gets you rockets that land. It gets you robots that can make drugs. It gets you poetry and art and communication. And then I often think, wouldn't it be great in bureaucracy to have another world war? Not literally a world war now, please, no world war, but the equivalent, so we could remove all the admin bureaucracy, right? All the admin violence, get rid of it and start again. Do you know what I mean?
Mm-hmm.
Because you get layers and you get redundant systems built. So actually, a reset, let's not call it violence, a reset in some aspects of our culture and our technology allows us to then build more important things without because how many cookies do I have to click on? How many extra clicks do I have in the future of my life that I could remove, and that a bit of a reset would allow us to start again. And maybe that's how I suppose our encounter with aliens will be. Maybe they will fight with us and say, we're not as excited by you as we thought. We'll just get rid of you.
Or they might want to reset Earth.
Yeah, why not?
To be like, let's see how the evolution runs again. This seems like there's nothing new happening here. They're observing for a while. This is just not. Let's keep it more fun. Let's start with a fish again. I like how you equated violence to resetting your cookies. I suppose that's the kind of violence. In this modern world where words are violence, resetting cookies.
I don't know where that came from. I'm completely, yeah.
That's poetic, really. Okay, so let's talk about life. What is life? What is non-life? What is the line between life and non-life? And maybe at any point we can pull in ideas of assembly theory.
Mm-hmm.
Like, how do we start to try to define life? And for people listening, so Sara identifies as a physicist and Lee identifies as a chemist. Of course, they are very interdisciplinary in nature in general. But so what is life? Sara?
Yeah.
I love asking that question because it's so absurdly big.
I know. I love it. It's my absolute favorite question in the whole universe. So I think I have 3 ways of describing it right now. And I like to say all 3 of them because people latch on to different facets of them. And so the whole idea of what Lee and I are trying to work on is not to try to define life, but to try to find a more fundamental theory that explains what the phenomena we call life. And then it should explain certain attributes. And you end up having a really different framing than the way people usually talk. So the way I talk about it 3 different ways. Life is how information structures matter across space and time. Life is... I don't know, this one's from you actually, simple machines constructing more complex machines. And the other one is the physics of existence, so to speak, which is life is the mechanism the universe has to explore the space of what's possible. That's my favorite.
So can I add on to that?
Yes.
Okay, can you say the physics one again? The physics of existence.
Yeah, the physics of existence. I don't know what to call it. Like if you think of all the things that could exist, only certain things do exist. And I think life is basically the universe's mechanism of bringing things into physically existing in the moment now.
Yeah.
Yeah. And what's another one?
So we were debating this the other day. So if you think about a universe that has nothing in it, that's kind of hard to conceive of, right? And this is where physicists really go wrong. They think of a universe with nothing in it. They can't. And you think
non-existence is really hard to think.
Yeah. And then if you think of a universe with everything in it, that's really hard. And you just have this white blob, right? It's just everything. But the fact we have discrete stuff in the universe beyond, say, planets. So you've got stars, space, planet stuff, right? The boring stuff. But I would define life, or say that life is where there are architectures, any architectures, and we should stop fixating on what is building the architectures to start with. And the fact that the universe has discrete things in it is completely mind-blowing. If you think about it for 1 second, the fact there's any objects at all, because for me, the object is a proxy for a machine that built it, some information being moved around, actuation, sensing, getting resource, and building these objects. So for me, everyone's been obsessing about the machine, but I'm like, forget the machine. Let's see the objects. And I think in a way that assembly theory, we realized maybe a few months ago that assembly theory actually does account for the soul in the objects, not mystically like, say, Sheldrake's morphic resonance or Leibniz's monadology, seeing souls in things. But when you see an object, and I've said this before, but this object is evidence of thought and then there's a lineage of those objects. So I think what is fascinating is that you put it much more elegantly, but the barrier between life and non-life is accruing enough memories to then actuate. So what that means is there are contingency, there are things that happen in the universe get trapped. These memories then have a causal effect on the future. And then when you get those concentrated in a machine and you're actually able in real time, able to integrate the past, the present with the future and do stuff, that's when you are most alive.
You being the machine.
Yes.
Wait a minute. Why is the object? So one of the ways to define life, that Sara said, is simple machines creating complex machines. So there's a million questions there. So how the hell does a simple machine create a complex machine?
By mutation. So this is what we were talking about at the beginning. You have the minimum replicator, so molecule. So this is what I was trying to convince Sara of the mechanism get there years ago, I think. But then you've been building on it and saying you have a molecule that can copy itself, but then there has to be some variability. Otherwise, it's not going to get more functional. So you need to add bits on. So you have a minimum molecule that can copy itself, but then it can add bits on, and that can be copied as well. And those add-ons can give you additional function. To be able to acquire more stuff to exist. So existence is weird, but the fact that there is existence is why there is life. And that's why I realized a few days ago that that's why alien life must be everywhere, because there is existence.
Is there like a conservation of cheeky stuff happening? So like, how can you keep injecting more complex things? Like, doesn't the machine that creates the object need to be as or more powerful than the things it creates? So how can you get complexity from simplicity?
So the way you get complexity from simplicity is that I'm just making this up, but this is kind of my notion. And you have a large volume of stuff. So you're able to get seeds, if you like, random cues from the environment. So you just use those objects to basically write on your tape, ones and zeros, whatever. And that is necessarily rich, complex, okay? But it has a low assembliness, but even though it has a high assembly number, we can talk about that. But then when you start to then integrate that all into a smaller volume as over time, and you become more autonomous, you then make the transition. I don't know what you think about that.
I think the easiest way to think about it is actually, which I know is a concept you hate, but I also hate, which is entropy. But people are more familiar with entropy than what we talk about in assembly theory. And also the idea that, like, say, physics as we know it involves objects that don't exist across time, or as Lee would say, low memory objects. So one of the key distinctions that is,
low memory objects.
Yeah. So physics is all
physicists are low memory
objects.
Quick clip.
But
Physicists are creators of low memory objects or manipulators of low memory objects.
Yep, absolutely.
It's a very nice way of putting it. Okay, sorry, go ahead.
No,
sorry to keep interrupting.
No, it's fine. I like it too. It's very funny. But I think it's a good way of phrasing it, because I think, this kind of idea we have in assembly theory is that, physics as we know it has basically removed time as being a physical observable of an object. And the argument I would make is that when you look at things like water bottles or us, we're actually things that exist that have a large extent in time. So we actually have a physical size in time, and we measure that with something called the assembly index in molecules. But presumably everyone should have sort of a do you want to explain what assembly?
Yeah, let's step back and start at the beginning. What is assembly theory? Lee sent me some slides. There's a big sexy paper coming out, probably, maybe, I don't know.
We've almost finished it.
Almost.
That's also a summary of science. We're almost done.
Yes.
Well, no, we're almost done.
I think the history of science.
We are ready
summarized.
to start an interesting discussion with our peers.
Right.
Yeah.
You're the machine that created the object, and we'll see what the object takes
Yeah.
us. All right. So what is assembly theory?
Yeah. Well, I think the easiest way for people to understand it is to think about assembly in molecules. Although the theory is very general, it doesn't just apply to molecules. And this was really Lee's insight, so it's kind of funny that I'm explaining it. But
I'll mark you.
Okay. All right. You ready? I'm ready. I'm ready. You
Go.
can tell me where I get the check marks minus, but
It's your theory as well.
yeah, I
so-
know. But imagine a molecule, and then you can break the molecule apart into elementary building blocks. They happen to be bonds, and then you can think of all the ways for molecular assembly theory. You can think of all the ways of building up the original molecule. So there's all these paths that you can assemble it, and the sort of rules of assembly is you can use pieces that have been generated already. So it has this kind of recursive property to it. And so that's where kind of memory comes into assembly theory. And then the assembly index is the shortest path in that space. So it's supposed to be the minimal amount of history that the universe has to undergo in order to assemble that particular object. And the reason that this is significant is we figured out how to measure that with a mass spec in the lab. And we had this conjecture that if that minimal number of steps was sufficiently large, it would indicate that you required a machine or a system that had information about how to assemble that specific object, because the combinatorial space of possibilities is getting exponentially large as the assembly index is increasing.
So just sorry to interrupt, but so that means there's a sufficiently high assembly index that, if observed in an object, is an indicator that something lifelike created it, or is the object itself lifelike?
Both. But you might want to make the distinction that a water bottle is not life, but it would still be a signature that you were in that domain of physics, and I might be alive. So,
So there will be potentially a lot of arguments about where the line, at which assembly index, does interesting stuff start to happen.
the point is, we can make all the arguments, but it should be experimentally observable. And Lee can talk more about that part of it. But the point I want to make about it is there was always this intuition that I had that there should be some complexity threshold in the universe above which you would start to say whatever physics governs life actually becomes operative. And I think about it a little bit like we have Planck's constant, which, and we have the fine structure constant. And then this sort of assembly threshold is basically another sort of potentially constant of nature. It might depend on specific features of the system, but which we debate about sometimes. But then when you're past that, you have to have some other explanation than the current explanations we have in physics, because now you're in high memory. Things actually require time for them to exist, and time becomes a physical variable.
So the path to the creation of the object is the memory.
Yep.
So you need to consider that.
Yeah, but the point is that's a feature of the object.
Right.
So so when I think of all the things in this room, we see the projection of them as a water bottle, but assembly theory would say that this is a causal graph of all the ways the universe can create this thing. That's what it is as an object. And we're all interacting causal graphs. And most of the creativity in the biosphere is because a lot of the objects that exist now are huge in their structure across time, 4 billion years of evolution to get to us.
So, is it possible to look at me and infer the history that led to me?
If
Me as a human,
you as an individual might be hard. You as a representative of a population of objects that have high assembly with similar causal history and structure that you can communicate with, i.e. other humans, you can infer a lot probably.
Yeah, also with them.
Which we do genomically even. I mean, it's not like we have a lot of information in us we can reconstruct histories from. Assembly is saying something slightly deeper.
Yeah, one thing to add, I mean, it's not just about the object, but the objects that occur, and not just objects with high assembly number, because you can have random things that have a high assembly number, but there must be a number of identical copies. So you're getting away from the random, because you could take a snapshot. This is why, it's not I hate entropy. I love entropy when used correctly, but it's about the problem with entropy is you have to have a labeler. And so you can label the beginning and the end, the start and the finish, where what you can do in assembly is say, I have a number of objects in abundance. They all have these features. And then you can infer. And one of the things that we debated a lot, particularly during lockdown, because I almost went insane trying to produce the assembly equation. So we came up with the assembly equation. Just imagine this. So you have this string where, actually it makes me sick trying to remember it, because it did my head in for a long time.
Dramatic.
Yeah, because I couldn't. So if you just have a string of, say, words, say, a series of words, series of letters. So you just have AAA, BBB, CCC, DDD, and you find that object, and you just have 4 A's, 4 B's, 4 C's, 4 D's together. Boom. Then, and that you measured that. So you physically measured that string of letters. Then what you could do is you can infer sub-graphs of maybe the 4As, the 4Bs, the 4Cs, and the 4Cs, but you don't see them in the real world. You just infer them. And I really got stuck with that because there's a problem to try and work out what's the difference between a long, a physical object and the assembly space of the objects. So that we realized the best way to put that is infer in time. So although we can't infer your entire history, we know at some point the 4As were made, the 4Bs was made, the 4Cs were made, and the 4Ds were made, and they all got added together. And that's one really interesting thing that's come out of the theory about the killer, when we knew we were going beyond beyond standard complexity theory, which was incredibly successful, is that we realized we could start to measure these things for real across domains. So the assembly index is actually an intrinsic property of all stuff that you can break into components. Particularly molecules are good because you can break them up into smaller molecules, into atoms. The challenge will be making that more general across all the domains, but we're working on it right now, and I think the theory will do that.
So components, domains, so you're talking about basically measuring the complexity of an object in what? Biology, chemistry, physics. That's what you mean by domains.
Complexity of Teslas,
sociology,
complexity of computers, complexity of memes.
Memes.
Yep.
What is that? Ideas.
Yeah, I mean, so one of the
Ideas are objects in assembly theory, though.
Yeah,
They're physical things. They're just features of the causal graph. I mean, the fact I can talk to you right now is because we're exchanging structure of our assembly space.
So conversation is the exchanging structures in assembly space.
Well,
What is assembly space?
When I started working on Origins of Life, I was writing about something called top-down causation, which a lot of philosophers are interested in, and people that worry about the mind-body problem. But the whole idea is, if we have, the microscopic world of physics is causally complete, it seems like there's no room for higher-level causes, like our thoughts, to actually have any impact on the world. And that seems problematic when you get to studying life and mind, because it does seem that quote unquote emergent properties do matter to matter. And then there's this other sort of paradoxical situation where information looks like it's disembodied. So we talk about information like it can just move from any physical system to any other physical system. And it doesn't require, you don't have to specify anything about the substrate to talk about information. And then there's also the way we talk about mathematics is also disembodied, right? Like the Platonic world of forms. And I think all of those things are hinging that we really don't know how to think about abstractions as physical things. And really, I think what assembly theory is pointing to is what we're missing there is the dimension of time. And if you actually look at an object being extended across time, what we call information and the things that look abstract are things that are entangled in the histories of those objects. They're features of the overlapping assembly space. So they look abstract because they're not, part of the current structure, but they're part of the structure if you thought about it as like the philosophical concept of a hyperobject, an object that's too big in time for us to resolve. And so I think information's physical. It's just physical in time, not in space.
Too hyperobject, too difficult for us to resolve. So we're supposed to think about of life as this thing that stretches through time, and there's a causation chain that led to that thing.
Mm-hmm.
And then you're trying to measure something with the assembly index about
the assembly index is the ordering, you could think of it as like a partial ordering of all the things that can happen. So in thermodynamics, we coarse grain things by temperature and pressure. In assembly theory, we coarse grain by the number of copies of an object and the assembly index, which is basically, if you think of the space of all possible things, it's like a depth of how far you've gone into that space and how much time was required to get there.
In the shortest possible version.
The shortest
Yes.
possible version.
Not average, because can't you just 3D?
You're going to
no.
kill me with that question.
Oh,
not 3D. Can't you always 3D print the thing?
Stab him in the heart.
no, because I had such fights. So Sarah's team and my team are writing this paper at the moment, and
It's so funny.
I think we kind of share at the beginning, you were like, no, that's not right. Oh, yes, right. And we're doing this for a bit.
Yeah.
And then the problem is when you build a theory and build the intuition, there's some certain features, right, of the theory that almost felt like I was being religious about, saying, right, you have to do this.
Yeah.
A good assembly theorist does this, does this, does this. And Sarah's postdoc Daniel and my postdoc Abhishek, and they were
We're
both
both brilliant.
they're brilliant, but they were both like, no, we don't buy that. And I was like, it is. They were like, well, Lee, actually, I thought you're the first to say that, you can't, if you can't explain it, it doesn't, and you can't do an experiment that doesn't exist. And that saved me. And I said to Abhishek's my postdoc in Glasgow, Daniel is Sarah's postdoc in ASU. I was like, I have the experimental data. So when I basically take the molecules and chop them up in the mass spec, the assembly number is never the average. It's always the shortest. It's an intrinsic property. And then the penny dropped for Abhishek. I said, okay. Because I had these things that we had to believe to start with or to trust, and then we've done the math and it comes out, and they now have the shortest path. Actually, it's up that explains why the shortest path. Here's why the shortest path is important, not the average. The shortest path needs you to identify when the universe has basically got a memory, not an average. So what you want to be able to do is to say, what is the minimum number of features that I want to be able to see in the universe? When I find those features, I know the universe has had a coherent memory and is basically alive. And so that gives you the lower bound. So that's like, of course, there's going to be other paths. We can be more ridiculous, right? Yeah. We can have other parts, but it's just the minimum. So probabilistically, at the beginning, because assembly theory was built as a measure for biosignatures, I needed to go there. And then I realized it was intrinsic. And then Sarah realized it was intrinsic and these hyperobjects were coming. And we were kind of fusing that notions together. And then the team were like, yeah, but if I have enough energy and I have enough resources, I might not take the shortest path. I might go a bit longer. I might take a really long path because it allows me then to do something else. So what you can do is, let's say I've got two different objects, A and B, and they both have different shortest paths to get them. But then if you want to make A and B together, they will have a compromise. So in the joint assembly space, that might be an average, but actually it's the shortest way you can make both A and B with a minimum amount of resource in time. Mm-hmm. So suddenly you then layer these things up. And so the average becomes not important, but as you literally overlap those sets, you get a new shortest path. And so what we realize time and time again when we're doing the math, that the shortest path is intrinsic, is fundamental, and is measurable, which is kind of mind-blowing.
So what we're talking about, some basic ingredients, maybe we'll talk about that, what those basic ingredients could be, and how many steps, when you say shortest path, how many steps it takes to turn those basic ingredients into the final meal. So how to make what's the shortest way to make a pizza?
Or a pie, an apple pie.
An apple pie, that's right.
And a pizza and a pie together.
From scratch.
Yeah.
So there's a lot of ways. There's the shortest way, and you take the full spectrum of ways, and there's probably an average, like duration for a noob to make an apple pie. Is the average interesting still? If you measure the average length of the path to assemble a thing, does that tell you something about the way nature usually does it versus something fundamental about the object, which I think is what you're aiming at with the assembly index?
Yeah. I mean, look, we all have to quantify things. The minimum path gives you the lower bound, so you know you're detecting something, you know you're inferring something. The average tells you about really how the objects are existing in the ecosystem or the technology. Mm-hmm. And there has to be more paths explored, because then you can happen upon other memories and then condense them down. I'm not making too much sense, but if you look at, let's just say, I mean, maybe we're going to get to alien civilizations later, right? But I would argue very strongly that alien civilization A and alien civilization B, they're different assembly spaces. So they're kind of going to be a bit messed up if they happen to come one another. Only when they find some joint overlap in their technology, because if aliens come to us and they don't share any of the causal graph we've shared, but hopefully they share the periodic table and some other and bonds and things, that we're going to have to really think about the language to talk to us aliens by using assembly theory to infer their language, their technology, and other bits and bobs. And the shortest path will help you do that quickly.
All right, so all aliens in this causality graphs have a common ancestor in the...
If the building blocks are the same, which means they live in the same universe as us.
So in this,
It
the
depends on
assumption,
how far back in time you go, though.
but the universe has all the same building blocks,
Yeah.
and like we have to assume that. So at least there's not different classes of causality graphs, right?
No.
The universe doesn't just say like, here you get the red causality graph and you get the blue one. These basic ingredients, and they're geographically constrained or constrained in space or time or something like that.
They're constrained in time because only by the virtue of the fact that you need enough time to have passed for some things to exist.
Sure.
So the universe has to be big enough in time for some things. So just at one point on the shortest path versus the average path, which I think we'll get to this, is you had a nice way of saying it's like the minimal compression is the shortest path for the universe to produce that. But it's also like the first time in the ordering of events that you might expect to see that object. But the average path tells you something about the actual steps that were realized, and that becomes an emergent property of that object's interaction with other objects. So it's not an intrinsic feature of that object, it's a feature of the interactions with other things. And so one of the nice features of assembly is you've basically gotten rid of, you just look at the things that exist and you've gotten rid of the mechanisms for constructing them in some sense. Like the machines are not as important in the current construction of the theory, although I would like to bridge it to some ideas about constructors. But then you can only communicate with things, as Lee was saying, if you have some overlap in the past history. So if you had an alien species that had absolutely no overlap, then there would be no means of communication. But as we become, as we progress further and further in time and more things become possible because the assembly spaces are larger, because you can have a larger assembly space in terms of index and also just the size of the space because it's exponentially growing, then more things can happen in the future. And the example I like to give is actually when we made first contact with gravitational waves, because that's an alien phenomena that's been permeating our planet, not alien in life phenomena, but alien, like something we had never knew existed. It's been, there's gravitational waves rippling through this room right now. But we had to advance to the level of Einstein writing down his theory of relativity, and then 100 years of technological development to even quote unquote see that phenomena.
So to see that phenomena, our causal graph had to start intersecting.
Yeah, we needed the idea to emerge first, the abstraction, right? And then we had to build the technology that could actually observe features of that abstraction.
So the nice promising thing is, over time, the graph can grow so it can start overlapping eventually.
Yeah. So the interesting feature of that graph is there was an event, 1.4 billion years away of a black hole merger that we detected on our detector. And, now suddenly we're connected through this communication channel with this distant event in our universe that, if you think about 1.4 billion years ago, what was happening on this planet, or even further back in time, that there's common physics underlying all those events, but even for those two events to communicate
now
with.
I understand what you were going on about the other week.
Yeah,
that's
I'm
really
sorry.
cool.
This
Yeah,
is
yeah,
a really
yeah,
abstract
yeah,
example,
yeah.
but
Your
it's
causal graphs are now overlapping.
Yeah, so well, let's just say now our causal graphs are overlapping in the deep past. Yeah,
No, I
sorry.
like it. So you made it.
I totally
the
missing.
1.6 billion.
Yeah.
Okay.
You made a connection with it. No, I do like that.
No, you can tell me what your epiphany is now. This is good.
Because I was.
And I should get the jokes before 30 seconds after. So.
Oh, I get it now. All right.
No, it's all right. I'm
The joke
slow.
from 2 minutes ago.
I'm slow on the uptake here.
I wasn't able to comprehend what you were talking about when saying the channel communicating to the past. But what you're saying is we were able to infer what happened 1.4 billion years ago. We detected the gravity wave. I mean, I think it's amazing that, at that time we were just becoming multicellular, right?
Yeah,
It's like insane. And then we progressed from multicellularity through to technology and built the detector, and then we just extrapolate backwards. So although we didn't do anything back to the graph back in time, we understood its existence then overlapped going forward, and that.
Well, that's because our graphs are larger.
Yeah, but that means that has a consequence. One of the things I was trying to say is like I think, I don't know, Sara might be, she can correct me, information first, and I'm a object first kind of guy. So I mean, as things that get constructed, there has to be this transition in random constructions. So when the object that's being constructed by the process bakes in that memory, and those memories then add on and add on and add on. So as it becomes more competent, and life is about taking those memories and compressing them, increasing their autonomy. And so I think that, like the cell that we have in biology on Earth is our way of doing that. That really the maximum ability to take memories and to act on the future.
Oh, I think that's mathematics.
No, mathematics doesn't exist.
No, but that's the point. The point is that abstractions do exist. They're real physical things. We call them abstractions, but the point about mathematics that I think is so I don't disagree. I think you're object first and I'm information first, but I think I'm only information first in the sense that I think the thing that we need to explain is what abstractions are and what they are as physical things. Because of all of human history, we've thought that there were these properties that are disembodied, exist outside of the universe, and really they do exist in the universe, and we just don't understand what their physics is. So I think mathematics is a really good example. We do theoretical physics with math, but imagine doing physics of math and then thinking about math as a physical object. And math is super interesting. I think this is why we think it describes reality so well, because it's the most copyable kind of information. It retains its properties when you move it between physical media, which means that it's very deep, and so it seems to describe the universe really well, but it probably is because it's information that's very deep in our past, and it's just we invented a way of communicating it very effectively between us.
Isn't math more fundamental? Isn't the assembly of the graph? Isn't basically I sound completely boring. It's like math, assembly theory invented math, but it did. It has to be.
Okay. So what is math exactly? It's a nice simplification, a simple description of what?
So we have a computer scientist, a physicist, and a chemist here.
Walk into a bar.
I think the chemist is going to define math, and you guys can correct me.
Go for it.
I would say
lay it on us, Lee. We're ready.
I think the ability to label objects and place them into classes and then do operations on those objects is what math is.
So on that point, what does it mean to be object first versus information first? So what's the difference between object and information when you get to that low fundamental level?
Well, I might change my view. So I'm stuff first, the stuff. Mm-hmm. And then when stuff becomes objects, it has to invent information. And then the information acts on more stuff and becomes more objects. So I think there is a transition to information that occurs when you go from stuff to objects.
I mean time, though.
Yeah.
Information is emergent? Then?
Not emergent. Information is actionable memories from the universe. So when memories become actionable, that's information.
But there's always memory, but it's not actionable.
Yeah, and then it's not information. Great.
And actionable is what you can create.
You can use it. If you can't use it, then it's not information. If you can't transmit it, if it doesn't have any causal consequence,
falls in the forest. I don't understand. Why is that not information?
It's not information. It's
stuff.
It's stuff happening, but it's not causal. Yeah. We can. This is
it's
cool.
happening.
No.
Happening requires information.
No.
Stuff is always happening.
No. This is where the physicists and the mathematicians get themselves in a loop, because they think the universe. I think say Max Tegmark and is very playful and say like the universe is just math. Well, if the universe is just math, then we may as well not bother having any conversation, because the conversation already written. We just may as well go to the future and say, can you just give us the conversation? It's happened already. So I think the problem is that mathematicians are so successful at labeling stuff and so successful understanding the stuff through those labels, they forget that actually those labels had to emerge and that information had to be built on those memories. So memory in the universe, so constraints, graph, when they become actionable and the graph can loop back on itself or interact with other graphs and they can intersect, those memories become actionable and therefore they're information. And I think you just changed my mind on something pretty big, but I don't have a pen, so I can't write. I'm going to write it down later. But roughly the idea is like you've got these two graphs of objects, of stuff. They have memories, and then when they intersect, and then they can act on each other, that's maybe the mechanism by which information is then. So then you can then abstract. So when one graph can then build another graph and say, hey, you don't have to go through all the nonsense we had to go through. Here's literally the way to do it. Stuff always comes first, but then when stuff builds the abstractions can be then teleported onto
And
other
the
stuff.
abstractions is the looping back
Yeah.
power. Okay.
Am I making? I don't know. I got stuck.
Yeah. So first, God made stuff.
Oh, yeah.
And after that, when you start to be able to form abstractions, that's when
God is the
information
memory the universe can remember.
God is the memory the universe can
Yeah.
remember. Otherwise, there's
Someone's
no.
gonna
Wait,
be
did you?
deciphering that statement hundreds of years from now? What the hell does that mean?
What do the humans
What?
mean by this?
Hey, look! Don't diss my one-liners.
No, I wasn't
took me,
dissing it. It was
took
just
me
it sounded very
15
deep.
seconds to come up with
I don't know what it means. What does it mean?
Okay, wait. We need to. How do we get onto this? We were time, causality, mathematics. So, what is mathematics in this picture of stuff, objects, memory, and information? What exactly is mathematics?
It's the most efficient labeling scheme that you can apply to lots of different graphs.
Well, the labeling scheme doesn't
sorry.
make it sound useful.
Can I try?
Yep, sure, please.
So,
Have you rejected my definition of mathematics? I'm
Yes.
shocked.
yeah, no, it's all right.
But it's correct. Go on, sorry.
Excellent. No, I mean, I think we have a problem, right? Because we can't not be us. Like we're stuck in the shells we are, and we're trying to observe the world. And so mathematics looks like it has certain properties. And I guess the thought experiment I find is useful is to try to imagine if you were outside of us, looking at us as physical systems using mathematics, what would be the specific features you associate to the property of understanding mathematics and being able to implement it in the universe, right? And when you do that, mathematics seems to have some really interesting properties relative to other kinds of abstraction we might talk about, like language or artistic expression. One of those properties is the one I mentioned already, that it's really easy to copy between physical media. So if I give you a mathematical statement, you almost immediately know what I mean. If I tell you the sky is blue, you might say, is it cobalt blue? Is it azure blue? What color blue do you mean? And you have a harder time visualizing what I actually mean. So mathematics carries a lot of meaning with it when it's copied between physical systems. It's also the reason we use it to communicate with computers. And then the second one is it retains its property of actually what it can do in the universe when it's copied. So the example I like to give there is think about like Newton's law of gravitation. It's a compressed regularity of a bunch of phenomena that we observe in the universe, but then that information actually is causal in a sense that it allows us to do things we wouldn't be able to do without that particular knowledge and that particular abstraction. And in this case, like launch satellites to space or send people to Mars or whatever it is. So if you look at us from the outside and you say, what is it for physical systems to invent a thing called mathematics, and then to use and then it to become a physical observable, mathematics is kind of like the universally copyable information that allows new possibility spaces to be opened in the future, because it allows this kind of ability to map one physical system to another and actually understand the general principles.
Yeah, so is it helping the overlap of causal graphs then?
Yes.
By mapping?
I think that's the explanation for what it is in terms of the physical theory of assembly, would be some feature of the structure of the assembly spaces of causal graphs and their relationship to each other. So, for example, and I mean, this is things that we're going to have to work out over the next few years. I mean, we're in totally uncharted conceptual territory here. But as is usual, diving off the deep end. But I would expect that we would be able to come up with a theory of like, why is it that some physical systems can communicate with each other? Like language. Language is basically because we're objects extended over time, and some of the history of that assembly space actually overlaps. And when we communicate, it's because we actually have shared structure in our causal history.
So let me have another quick go at this, right? So I think we all agree. So I think we take mathematics for granted because we've gone through this chain, right? Of we all share a language now, okay? And we share so we have languages that we can make interoperable, and so whether you're speaking, I don't know, all the different dialects of Chinese, all the different dialects of English, French, German, whatever, you can interconvert them. The interesting thing about mathematics now is that everybody on planet Earth, every human being and computers share that common language.
Yeah.
That language was constructed by a process in time. So what I'm trying to say is that assembly invented math. Is right from the mathematics didn't occur. It didn't exist before life. Abstraction was invented by life, right? That doesn't mean that the universe wasn't capable of mathematical things.
Wait a minute. Can we just ask that old famous question: is math invented or discovered? So when you say assembly invented or whatever,
Well, someone
it
might
means
refer assembly as a mathematical theory, but sorry.
right.
Are we arguing?
Exactly.
Are we arguing now?
That's what it sounds like. Are we discovering?
No. Well, yes and no. I would say.
And you called mathematics a language.
I would say
developing.
Look, I'm pretty sure that there are some very common seeds of mathematics in the universe, right? But actually, a lot of the mathematics that we are finding now is not discovered; it's invented. But even though I think those two terms are very triggering, and I don't think they're necessarily useful, because I think that what people do, the mathematicians that say, "Oh, mathematics was discovered," because they live in a universe where there is no time and it just all exists. But what I'm saying is, and I think in the same way you can create, let's say I'm going to go and make a piece of art. Did I make that piece of art or did I discover it? Like inventing the airplane. Did I invent the airplane? Let's stick with the airplane. The airplane is a good one. Let's say did I discover the airplane? Well, in a way, the universe discovered the airplane because it just chucked a load of atoms together and a load of random human beings want to do stuff, and we discovered the airplane in the space of possibilities. But here's the thing: when the space of possibilities is so vast, infinite almost, and you're able to actualize one of those in an object, then you are inventing it. So in mathematics, because there are an infinite number of theorems, the fact you're actually pulling, there's no difference between inventing a mathematical structure and inventing the airplane. They're the same thing. But that doesn't mean that now the airplane exists in the universe is something weird about the universe. So I think that the more, this is the thing that the more memory required for the object, the more invented it is. So when a mathematical theorem needs more bytes to store it, the more invented it is, and the less bytes, the more discovered it is.
But everything then is invented. It's just more or less invented.
Absolutely.
The universe has to generate everything as it goes.
Yeah.
And it wasn't there in the beginning. And the way we're thinking it, when you're thinking about the difference between invented and discovered, is because we're throwing away all the memory.
Yeah.
So if you start to think in terms of causality and time, then those things become the same. Everything is invented.
And the idea is to make everything intrinsic to the universe. So I think one of the features of assembly theory is we don't want to have external observers. There's been this long tradition in physics of trying to describe the universe from the outside and not the inside. And the universe has to generate everything itself if you do it from the inside.
Assembly theory describes how the universe builds itself.
Mm-hmm. Did it take you 15 seconds to say that?
Yeah.
To come up with that also?
No, I've thought of that before.
Okay. It's a good line. It's like.
Are you making fun again?
No, I'm not making fun. I'm having fun. There's a difference.
Oh, that's good. All right.
She's inventing fun.
I'm not all intimidated.
Yes.
And there's a causal history to that fun. You mentioned that there's no way to communicate with aliens until there's overlap in the causal graph. Communication includes being able to see them? And like, what are we... This is the question is communication any kind of detection? And if so, what do aliens look like as you get more and more overlap on the causal graph?
Let's assume that so when you see them and they see you, you're assuming they have vision, they have the ability to construct in 3D and in time. There's a lot of assumptions we're making.
What detection? All right, let's step back. So yes, okay, you're right. So when in the English language, when we say the word see, we mean visually. They show up to a party and it's like, oh, wow, that's an alien. That's visual. That's 3D. That's okay. And that's also assuming scale, spatial scale of something that's visible to you. So it can't be microscopic or it can't be so big that you don't even realize that's an entity. Okay. But other kinds of detection too.
I would make it more abstract and go down. I was thinking this morning about how to rewrite the Arecibo message in assembly theory and also to abandon binary. Because I don't think aliens necessarily... Why should they have binary?
Well, they have some basic elements with which to do information exchange. So
But let's make it more fundamental, more universal. So we need to think about what is a universal way of making a memory, and then we should re-encode Arecibo in that way.
What's more basic than zeros and ones?
Well, it's really difficult to get out of that causal chain because we're so let's erase the idea of zero for a moment. It took human beings a long time to come up with the idea of zero. Now you got the idea of zero. You can't throw it away. It's so useful.
To discover the idea of zero.
To discover or invent.
I don't know. But it took a long time, so it was invented. That's right.
Yeah, I think zero was invented. So exactly. So it's not a given that aliens know what zero is.
They just have the one.
A massive assumption.
It's a useful discovery. You're saying if you break the causal chain, there might be some other more efficient way of representing.
That's why I want to meet him and ask him
for a shortcut. But you won't be able to ask him until.
What? So I interrupted you, and I think you're making a good point. I was just going to say, well, look.
Thank you.
Sorry. Rather than saying,
please, internet, tweet at him for the rude interruptions. Oh, go ahead. I'm sorry.
No, it's okay. Maybe it's change. How do we? So, I don't know what it's like to be an alien. I would like to know.
What is the full spectrum of what aliens might look like to us? Now that we've laid this all on the table of like, all right, so there has to be some overlap in this causal chain that led to them. What are we looking for? What do you think we should be looking for? So you mentioned mass spec, measuring certain objects that aliens could create or are aliens themselves. We show up to a planet, or maybe not a planet, or maybe what the hell is the basic object we're trying to measure the assembly index of?
Let's cut ourselves a break. Let's assume that they're metabolized. They've got an energy source, and they're a size that we can recognize. Let's cut ourselves a break, because there could be aliens that are so big we won't recognize we're seeing them. There might be aliens that are so small we don't yet have the ability to, we don't have microscopes that can see, far enough away that just won't be able to see them.
So what's a good range?
So let's just make a range. Let's just be very anthropocentric and say we're going to look for aliens roughly our size and technology our size, because we know it's possible on Earth, right? I mean, a reasonable thing to do would be to find exoplanets that are in the same zone as Earth in terms of heat and stuff, and then say, hey, if there's that same kind of gravity, same kind of stuff, we could reasonably assume that the alien life there might use a similar kind of physical infrastructure, and then we're good. So then your question becomes really relevant. Say, right, let's use vision, sound, touch.
Right. And so, okay, that's really nice. So that if there's a lot of aliens out there, there's a good likelihood, if you match to the planet, that they're going to be in the same spatial and temporal, operating in the same spatial and temporal domain as humans. Okay, within that, what do they look like visually? What do they sound like? What do they? Oh God, this sounds creepy. Taste like? What do they? Smell like? Smell like? That's.
It sounds like our clubhouse. And was like, "Can we have sex with aliens?" Which was basically me saying,
passionate love.
But it wasn't actually about sex. It was about, is our chemistry compatible? Right?
Yes.
Is there some?
Yeah.
So yeah. Can we? Yeah. Are they edible too? They could be very edible. They could be delicious.
That's why I want to see some aliens, right? Because I think evolution. Evolution exploits symmetry, right? Because why generate memory? Why generate storage? The need for storage space when you can use symmetry. So, and symmetry is maybe quite effective in allowing you to mechanically design stuff, right? Mm-hmm. So maybe you could be reasonable to assume that aliens they could be bipedal. They could be symmetric in the same way, might have a couple of eyes or a couple of sensors. I mean, we can make that. And perhaps there's this whole zoo of different aliens out there, and we'll never get to be able to classify some of the weird aliens we can't interact with because they have made such weird stuff.
Yeah.
But we are just going to we're going to find aliens that look most like us. Why not?
Because those are the first ones we're likely to see.
Yeah.
But I think it's really hard to imagine what the space of aliens is, because the space is huge. Because, like one of the arguments that you can make about why life emerges in chemistry is because chemistry is the first scale in terms of building up objects from elementary objects. that the number of possible things that could exist is larger than the universe can possibly make all at once, right? So, so you imagine you have two planets and they're cooking some geochemistry. Our planet invented one kind of biochemistry, and presumably, as you start building up the complexity of the molecules, the chances of the overlap in those trajectories, those causal chains being built up, is probably very low. And it gets lower and lower as it gets farther advanced along its evolutionary path. So I think it's very difficult to imagine predicting the technologies that aliens are going to have. I mean, you're looking at basically planets have kind of convergent chemistry, but there's some variability, and then you're looking basically at the outgrowth into the possibility space from chemistry.
So do you think we would detect the technology, the objects created by aliens before we detect the aliens?
Possibly.
So when you're talking about measuring assembly index, don't you think we would detect the garbage first? Like at the outskirts of alien civilizations, is it just going to be trash?
I think I would come back to Arecibo. The Arecibo message sent from the Arecibo telescope, built by Drake, I think, and Sagan.
How's Arecibo spelled?
Arecibo.
Yes. Thank you.
A-R-C-A-S.
And there we go. They've got it up there.
That's this telescope that sent the message that you're talking about.
So that message was sent where?
It was beamed at a star, a specific star, and it was sent out many years ago. And what they did, so this is why I was pushing on binary. It's a binary message. I think it's a semi-prime number of characters. So I think 73 by 23, I think. And it basically represents human proton, binary, human beings, DNA, male and female. And it's really cool. Mm-hmm. But I'm just wondering if it could be done not making any, because it's made assumptions that aliens speak binary. Why make that assumption? Why not just assume that if the difference between physics, chemistry, and biology is the amount of memory that's recordable by the substrates, then surely the universal thing, I'm going to make some sacrilegious statement, which I think is pretty awesome for people to argue with.
So this is, we're looking at an image where it's the entirety of the message encoded in binary, and then there's a probably interpretation of different parts of that image. There's a person, there's green parts. It looks like, for people just listening, like a game of Tetris. So it's encoding in minimal ways a bunch of cool information, probably
representing all of us. Apparently.
So at the top, it's kind of teaching us how to count, and then it all goes all the way down teaching you chemistry, and then just says, but it makes so many assumptions. And I think if we can actually, so look, Sarah's much more eloquent expressing this, but I'll have a go and you can correct it if you want, which is like, one of the things that Sara has had a profound effect on the way I look at the origin of life. And this is one of the reasons why we're working together, because we don't really care about the origin of life. We want to make life, make aliens and find aliens, make aliens, find aliens. I think we might have to make aliens in the lab before we find aliens in the universe, right? Mm-hmm. I think that would be a cool way to do it. So what is it about the universe that creates aliens? Well, it's selection through assembly theory, creating memories. Because when you create memories, you can then command your domain. You can basically do stuff. You can command matter. So we need to find a way, by understanding what life is, of how the minimal way to command matter, how that would emerge in the universe. And if we want to communicate, maybe we don't want to necessarily uniformly communicate. What I would do perhaps if I would send out lots of probes away from Earth that have this magic way of communicating with aliens, get them quite far away from Earth, plausibly deniable, and then send out the message that would then attract all the aliens, and then basically work out if they're a friend or foe and how they want to hang out.
The message is being something that has to do with the memories?
Yes. Like the assembly version of Arecibo, so that everyone in the universe that understands what life is. So aliens need to work out what they are. Once they've worked out what they are, they then can work out how to encode what they are, and then they can go out and send messages. It's like the universal, the Rosetta Stone for life in the universe is working out how the memories are built. I don't know if, Sara, you have any, whether that you would agree with that.
No, I wanted to raise a different point, which is about the fact that we can't see the aliens yet because we haven't gotten the technology. And presumably, we think assembly theory is the right way of doing it, but I don't think that we know how to go from the kind of data you're describing, Lex, like, visual data or smell, to construct the assembly spaces yet. And in some ways, I think that the problem of life detection really is the same problem at the foundations of AI, that we don't understand how to get machines to see causal graphs, to see reality in terms of causation. And so I think assembly and AI are going to intersect in interesting ways, hopefully. But the sort of key point, and I've been trying to make this argument more recently, and might write an essay on it, is, people talk about the great filter, right? And which is, again, this like doomsday thing that, people want to say there's no aliens out there because something terrible happened to them. And it matters whether that's in our past or our future as to the longevity of our species, presumably, which is why people find it interesting. But I think it's not a physical filter. It's not like things go extinct. I think it's literally we don't have the technology to see them. And you could see that with microscopes. I mean, we didn't know there were microbes on this table or tables for thousands of years, or telescopes. Like, there's so much of the universe we can't see. And then basically what we have done as a species is outsource our physical perceptions to technology, building microscopes based on our eyes, and building seismometers based on our sense of feeling to like feel earthquakes and things. And AI is basically, we're trying to outsource what's actually happening in our thinking apparatus into machines now, into technological devices. And maybe that's the key technology that's going to allow us to see things like us and see the universe in a totally different way.
But you kind of mentioned the great filter. Do you think there's a way through technology to stop being able to see stuff? So can you take a step backwards?
I think so, yeah.
Did you imply that with the great, so like...
Well, no, I mean, I think there's a great perceptual filter in the sense that a example of life evolving on a planet over billions of years has to acquire a certain amount of knowledge and technology to actually recognize the phenomena that it is.
Well, that's the sense I have is, I mean, you talk with physicists, engineers in general, there's this kind of idea that we have most of the tools already to hear the signal. But to me, it feels like we don't have any of the tools to see the signal.
What we're doing. Yeah, I agree.
That's the biggest, to hear. We don't have the tools to really hear, to see.
Yeah.
Aliens are everywhere. We just don't have the
Exactly.
I mean, well, that's...
I mean, I got this in part actually because you were like, last time I was here, you were like, look at the carpet. Could it, like, if we had an alien detector, would the carpet be aliens? I mean, I think we really don't.
So they would be, but the aliens would nevertheless have a high assembly index or produce things of high assembly index.
Yeah.
And those things of a high assembly index, you have to have a detector that can recognize high assembly index in all its forms.
Yeah.
Yes.
That's it.
Take data, construct assembly space.
Yeah.
Those patterns, basically. So one way to think about high assembly index is interesting patterns of basic ingredients.
I can give you an example because, I mean, in molecules, we've been talking about in objects, but we're also trying to do it in spatial trajectories. Like, imagine you're just, I always get bothered by the fact that, like, when you look at birds flocking, you can describe that with like a simple Boyd's model, or like, people use spin glass to describe animal behavior. And those are like really simple physics models. Yet you're looking at a system that has agency and there's intelligence in those birds. And basically, like, you can't help but think there must be some statistical signatures of the fact that that's a group of agents versus, like, I don't know, the physics example, maybe like, I don't know, Brownian motion or something. And so what we're trying to do is actually apply assembly to trajectory data to try to say there's a minimal amount of causal history to build up certain trajectories for observed agents. That's like an agency detector for behavior.
Do you think it's possible to do some like Boyd's or those kinds of things, like artificial, like cellular automata, play with those ideas with assembly? With assembly theory, have you found any useful, really simple mathematical like simulation tools that allow you to play with these concepts? So like one, of course, you're doing mass spec in this physical space with chemistry, but it just seems, well, I mean, computer science person, maybe it seems easier to just,
I agree with you,
and sexier in terms of tweeting visual information on Twitter or Instagram, more importantly, to play like, here's an organism of a low assembly index and here's an organism of a high assembly index, and let's watch them create more and more memories and more complex objects. And so, like, and mathematically, you get to observe what that looks like to build up an intuition what assembly index is like.
We are building a toolkit right now. So I think it's a really good idea. But what we've got to do is, I'm kind of still obsessed with the infrastructure required. And one of the reasons why I was pushing on information and mathematics, when we take a lot of the infrastructure for granted. And I think we have to strip that back a bit for going forward. But you're absolutely right. I would agree that I think the fact that we exist in the universe, this is like, I can see that lots of people can disagree with this statement, but I don't think Sarah will. But I don't know. The fact that objects exist, I don't think anyone on Earth will disagree that objects can exist elsewhere, right? But they will disagree that life can exist elsewhere. But what perhaps I'm trying to say is that the acquisition, the universe's ability to acquire memory, is the very first step for building life, and that's so easy to happen. So therefore, alien life is everywhere, because all alien life is those memories being compressed and minimalized, and the alien equivalent of the cell working. So I think that we will build new technologies to find aliens, but we need to understand what we are first, and how we go from physics to chemistry to biology. The most interesting thing, as you're saying, to these two organisms, different assemblies, is when you get into biology gets more and more weird, more and more contingent. Where chemistry is less weird because the rules of chemistry are smaller than the rules of biology, and then going all the way to physics, where you have a very nicely tangible number of ways of arranging things. And I think assembly theory just helps you appreciate that. And so once we get there, my dream is that we are just going to be able to suddenly I'm maybe just being really arrogant here. I don't mean to be arrogant. It's just, again, I've just got this hammer called assembly and everything's a nail. But I think that once we crack it, we'll be able to use assembly theory plus telescopes to find aliens.
Sarah, do you have disagreements with Lee on the number of aliens that are out there?
I do, actually, yeah. Well,
and what they look like. So any of the things we've been talking about, is there nuanced? Oh, it's always nice to discover wisdom through nuanced disagreement.
Yeah, I don't wholly disagree, but I think but I do think I disagree. It's kind of there's nuance there. But
you can disagree.
No, it's fine. It is nuanced, right? So you made the point earlier that you think once we discover what life is, we'll see alien life everywhere. And I think I agree on some levels, in the sense that I think the physics that governs us is universal. But I don't know how far I would go to say that we're a likely phenomena, because we don't understand all of the features of the transition at the origin of life, which we would just say in assembly is you go from the no memory physics to there's like a critical transition around the assembly index, where assembliness starts to increase, and that's what we call the evolution of the biosphere and complexification of the biosphere. So there's a principle of increasing assembliness, or that goes back to what I was saying at the very beginning about the physics of the possible, that the universe basically gets in this mode of trying to make as much possibilities as possible. Now, how often that transition happens, that you get the kind of cascading effect that we get in our biosphere, I think we don't know. If we did, we would know the likelihood of life in the universe. And a lot of people want to say life is common, but I don't think that we can say that yet till we have the empirical data, which I think you would agree with. But then there's this other kind of thought experiment I have, which I don't like, but I did have it, which is, if life emerges on one planet and you get this real high density of things that can exist on that planet, is it sort of dominating the density of creation that the universe can actually generate? So like if you're thinking about counting entropy, right? Like the universe has a certain amount of stuff in it. And then, assembly is kind of like an entropic principle. It's not entropy. But the idea is that now transformations among stuff, or the actual physical histories of things, now become things that you have to count, as far as saying that these things exist and we're increasing the number of things that exist. And if you think about that cosmologically, maybe Earth is sucking up all the life potential of the whole universe. I don't know. But I have
How's that? Can you explain that a little bit? Why can any one geographical region suck up the creative capacity of the universe?
Just like
No.
I know it's a ridiculous thought. I don't actually agree with it, but it was just a thought experiment.
I love that you can have thoughts that you don't like and don't agree with, but you have to think through them anyway.
Yeah.
Those are,
I
the
just
human mind is fascinating.
Yeah, I think these sort of like counterfactual thought experiments are really good when you're trying to build new theories because you have to think through all the consequences. And there are people that want to try to account for, say, the degrees of freedom on our planet in cosmological inventories of, talking about the entropy of the universe and, and when we're thinking about like cosmological arrow of time and things like that. Now, I think those are pretty superficial proposals as they stand now, but assembly would give you a way of counting it. And then the question is, if there's a certain maximal capacity of the universe's speed of generating stuff, which Lee always has this argument that assembly is about time, the universe is generating more states. Really, what it's generating is more assembly possibilities. And then dark energy might be one manifestation of that the universe is accelerating its expansion because that makes more physical space. And what's happening on our planet is it's accelerating in the expansion of possible things that exist. And maybe the universe just has a maximal rate of what it can do to generate things. And then if there is a maximal rate, maybe only a certain number of planets can actually do that, or there's a trade-off about the pace of growth on certain planets versus others.
I have a million questions there, but do you have thoughts on what Sarah
Just a
said?
quick, I'll just say something very
It's
quick.
a thought experiment.
No, it's good. I think I get it.
Yeah.
I think I get it. So, all I want to say is, when I mean aliens are everywhere, I mean memories are the prerequisite for aliens via selection and then concentration of selection when selection becomes autonomous. So what I would love to do is to build, say, a magical telescope that was a memory a magical one, or a real one that would be a memory detector to see selection.
Mm-hmm.
So you could get to exoplanets and say that exoplanet looks like there's lots of selection going on there. Maybe there's evolution and maybe there's going to be life. So what I'm just trying to say is narrow down the regions of space where you can say there's definitely evidence of memory as high assembly there, or not high assembly because that would be life, but of where it's capable of happening, and then that would also help us frame the search for aliens. I don't know how likely it is to make the transition to cells and all the other things. I think you're right, but I think that we just need to get more data.
Well, I didn't like the thought experiment because I don't like the idea that if the universe has a maximal limit on the amount it can generate per unit time, that our existence is actually precluding the existence of other things.
I'll just say one thing.
But I think that's probably true anyway because of the resource limitations.
So I don't like your thought experiment because I think it's wrong. No. I do like the thought experiment. So what you're trying to say is like there is a chain of events that goes back that's manifestly culminated with life on Earth. Mm-hmm. And you're not saying that life isn't possible elsewhere. You say that there has been these number of contingent things that have happened that have allowed life to emerge here. That doesn't mean that life can't emerge elsewhere, but you're saying that the intersection of events may be concentrated here, right? And I think that's
not exactly. It's more like if you look at, say, the causal graphs are fundamental, maybe space is an emergent property, which is consistent with some proposals in quantum gravity, but also how we talk about things in assembly theory, then the universe is causal graphs generating more structure in causal graphs, right? So this is how the universe is unfolding. And maybe there's a cap on the rate of generation, like there's only so much stuff that gets made per update of the universe. And then if there's a lot of stuff being made in a particular region that happens to look the same locally, spatially, that's an after effect of the fact that the whole causal graph is updating. Like it's
yeah, I don't know that. I think that doesn't work.
I don't think it works either, but I don't have a good argument in my mind about.
But I do like the idea of the capacity that the universe, because you've got a number of states. Yeah, we can come back to it.
Well, let me ask real quick. Like, why does different like local pockets of the universe start remembering stuff? How does memory emerge exactly? So at the origin of the universe, it was very forgetful. That's when the physicists were happiest. It was low memory objects, which is like ultra low memory objects, which is what the definition of stuff. Okay, and so how does memory emerge? How does the temporal stickiness of objects emerge?
I'm going to take a very chemocentric point of view because I can't imagine any other way of doing it. You could think of other ways, maybe, but I would say heterogeneity in matter is where the memory. So you must have enough different ways of rearranging matter for there to be a memory. So what that means is if you've got particles colliding in a box, let's just take some some elements in a box. Those elements can combine in a combinatorial set of ways. So there's a combinatorial explosion of the number of molecules or minerals or solid objects, bonds being made. Because there's such a large number, the population of different objects that are possible. This goes back to assembly theory, where assembly theory, there's 4 types of universes, right? So you've got basically and this is what one was up earlier, where one universe where you've just got everything is possible. So you can take all the atoms and combine them and make everything. Then you've got basically what is the assembly combinatorial, where you basically have to accrue information in steps. Then you've got assembly observed, right? And then you've got the object assembly going back. Mm-hmm. So what I'm trying to say is, like, if you can take atoms and make bonds, let's say you take a nitrogen atom and add it to a carbon atom, you find an amino acid, then you add another carbon atom on in a particular configuration, then another one, all different molecules, they all represent different histories. So I would say for me right now, the most simple route into life seems to be through recording memories and chemistry. But that doesn't mean there can't be other ways and can't be other emergent effects. But I think if you can make bonds and lots of different bonds, and those molecules can have a causal effect on the future. So imagine a box of atoms, and then you combine those atoms in some way. So you make molecule A from a load of atoms, and then molecule A can go back to the box and influence the box. Then you make A prime or AB or ABC, and that process keeps going, and that's where the memories come from, is that heterogeneity in the universe from bonding. I don't know if that makes any sense.
And it's beginning to flourish at the chemistry level.
Yeah.
So the physicists have not enough.
Yeah. I mean,
they're like desperately begging.
Well, the physicists will claim
freedom.
Yeah.
And heterogeneous components to play with.
Yeah, that's exactly it.
What do you think about that, Sarah?
I mentioned already, I think it's significant that whatever physics governs life emerges actually in chemistry. It's not relevant at the subatomic scale or even at the atomic scale. It's atomic scale because chemistry. But like when you get into this combinatorial diversity that you get from combining things on the periodic table, that's when selection actually matters, or the fact that some things can exist and others can't exist actually starts to matter. So I think of it like you don't study gravity inside the atomic nucleus. You study it in terms of the large scale structure of the universe or black holes or things like that. And whatever we're talking about as physics of information or physics of assembly becomes relevant at a certain scale of reality. And the transition that you're talking about, I would think of as just when you get a sufficient density in terms of the assembly space, of like the relationship of the overlap and the assembly space, which is like a feature of common memory, there is this transition to assembly dominated physics, whatever that is. When we're talking about, and we're trying to map out exactly what that transition looks like. We're pretty sure, of some of its features, but we haven't done all of the.
Do you think if you were there in the early universe, you would have been able to predict the emergence of chemistry and biology? And I ask that because at this stage, as humans, do you think we can possibly predict the length of memory that might be able to be formed later on in this pocket of the universe? Like how complex is what is the ceiling of assembly?
I think as much time as you have in the past is how much you can predict in the future, because that it's actually physical in the system, and you have to have enough time for features of that structure to exist.
Wait, let me push back on that. Wait, what isn't there somewhere in the universe that's like a shortest path that stretches all the way to the beginning?
Yeah,
that's building some giant monster.
Right. Maybe, yeah.
Yeah.
So you
the
can't
universe has as
monster.
much memory as the largest assembly object in the universe.
Yeah.
Right. But so you can't predict.
You can't predict any deeper than that. No.
Right. So like that, I guess what I'm saying is, like, what intuition do you have about complexity living in the world that you'd have today? Right. Because you can, I mean, I guess how long,
well, you
does it
couldn't
get
have
more
predicted
fun?
it.
Like, isn't there going to be at some point, because there's a heat death in the universe, isn't there going to be a point of the most of the highest assembly of object with the highest probability being generated all the time.
When is the universe going to be the most fun, and can we freeze ourselves and then live then?
Exactly. And will you know when you're having the most fun that this is the best time you're in your prime? Or are you going to do what everyone does, which is deny that you're in your prime and the best years are still ahead of you? I don't know.
What option do you have? I don't. I mean, the problem is there's lots of really interesting features here. I just want to mention one thing that might be is that I do think assembly theory applies all the way back to subatomic particles, and I also think that cosmological selection might have been actually there might have been it's not, I would say it's a really boring bit, but it's really important if you're a cosmologist that universes have gone through. Was it Lee Smolin who proposed this? Maybe that there is this that basically a universe evolves. You've got the wrong constants. We'll start again. And the most productive constants where you can allow particles to form in a certain way, get propagate to the next universe, and we go again. So actually selection goes all the way back, and there's these cycle of universes. And now this universe has been selected because life can occur, and it carries on. But I've really butchered that. There is a much more...
So there's some aspect where through the selection process, there's parameters that are being fine-tuned, and we happen to be living in one where there's some level of fine-tuning. Is there, given that, can you steel man the case that we humans are alone in the universe? We're the highest assembly index object in the universe.
Yeah, I can, I guess. Sad though. I mean, so
is it possible?
Yes, it's possible. Let's assume. Well, we know. I mean, it's possible. So let me. So there is a particular set of elements on Earth in a particular ratio, and the right gravitational constant, and the right viscosity, of stuff being able to move around, the right distance from our sun, the right number of events where we have a moon, the Earth is rotating, the late heavy bombardment produced a lot of brought in the right stuff, and Mars was cooking up, the right molecules first, so it was habitable before Earth. It was literally doing the combinatorial search, and before Mars kind of became uninhabitable, it seeded Earth with the right molecular replicators, and there was just the right stuff on Earth, and that's how the miracle of life occurred. Although I find I'm very uncomfortable with that because life came so quickly in the Earth's past. But that doesn't mean that life is easy elsewhere. It just might mean that because chemistry is actually not a long-term thing. Chemistry can happen quickly. So maybe going on with the steel manning of the argument to say, actually, the fact that life emerged quickly doesn't mean that life is easy. It just means that the chemistry was right on Earth, and Earth is very special. And that's why there's no life anywhere else in the universe.
Yeah. So Sara mentioned this kind of cascading thing. So what if that's the reason we're lucky, is that we got to have a rare cascading of like an accelerating cascading effect in terms of the complexity of things. So like maybe most of the universe is trying to get sticky with the memory, and it's not able to really form it, and then we got really lucky in that, and it has nothing, like there's a lot of Earth-like conditions, let's say, but it's just you really have to get lucky on this.
But I'm doing experiments right now. In fact, experiments that Sara and I are working on because we have some joint funding for this, where we're seeing that the universe can get sticky really quickly. Now, of course, we're being very anthropocentric. We're using laboratory tools. We're using theory, but actually, the phenomena of selection, the process of developing heterogeneity, we can do in the lab. We're just seeing the very first hints of it. And wouldn't it be great if we can start to pin down a bit more precisely, becoming good Bayesianists for this, for the origin of life and the emergence of life, to finding out what kind of chemistries we really need to look for. And I'm becoming increasingly confident we'll be able to do that in the next few years. Make life in the lab, or make some selection in the lab from inorganic stuff, from sand, from rocks, from dead stuff, from moon. Wouldn't it be great to get stuff from the moon, put it in our origin of life experiment, and make moon life and restrict ourselves to interesting self-replicating stuff that we find on the moon?
Sarah, what do you think about this approach of engineering life in order to understand life? So building life in the machine.
Yeah. So, I mean, Lee and I are trying right now to build the vision for a large institute or experimental program, basically, to do this problem. But I think of it as like we need to simulate a planet. So, like the Large Hadron Collider was supposed to be simulating conditions just after the Big Bang. Lee's built a lot of technology in his lab to do these kind of selection engines. But the question you're asking is how many experiments do you need to run? What volume of chemical space do you need to explore before you actually see an event? And I like to make an analogy to one of my favorite particle physics experiments, which is Super Kamiokande, that's looking for the decay of the proton. So this is something that we predicted theoretically, but we've never observed in our universe. And basically, what they're doing is every time they don't see a proton decay event, they have a longer bound on the lifetime of a proton. So imagine we built an experiment with the idea in mind of trying to simulate planetary conditions, physically simulate. You can't simulate origin of life in a computer, you have to do it in an experiment. Simulate enough planetary conditions to explore the space of what's possible and bound the probability for an origin of life event. Even if you're not observing it, you can talk about the probability. But we hopefully, life is not exponentially rare, and we would then be able to evolve in an automated system alien life in the lab. And if we can do that, then we understand the physics as well as we understand what we can do in particle accelerators.
So keep expanding physically the physical simulation until something happens.
Yeah, or just build a big enough volume of chemical experiments and
So
evolve
when you
them.
say volume, you mean like literally volume.
I mean physical volume in terms of space, but I actually mean volume in terms of the combinatorial space of chemistry. So,
How do you nicely control the combinatorial exploration, the search space,
No,
such that it's always like you keep grabbing the low hanging fruit?
yeah, how do you build a search engine for chemistry to
I
look
think
for
you explained it really
aliens?
well. We should carry on doing this. I should pretend be the physicist, you be the chemist. No, so the way to do it is I will always play a joke because I like writing grants to ask for money to do cool stuff. And I years ago I started wanting to build. So I actually wanted so I built this robot in my lab called the Computer, which is this robot you can program to do chemistry.
Mm-hmm.
Now I made a programming language for the Computer and made it operate chemical equipment. Originally, I wrote grants to say, hey, I want to make an origin of life system. And no one would give me any money for this. They said, what, this is ridiculous. Why are you wanting to make it's really hard. It takes forever. You're not a very good origin of life chemist anyway. Why would we give you any money? And so I turned it around and said, can you give me money to make robots, to make molecules that are interesting? And everyone went, yeah, okay, you can do that. And that's so actually the funny thing is the Computer project, which I have in my lab, which is very briefly, it's just basically, it's like literally an automated test tube. And we've made a programming language for the test tube, which is cool. Has literally came from this. I went to my lab one day and said, I want to make a search engine to get the origin of life because I don't have a planet. And I thought about doing it in a microfluidic format. So microfluidic is very very small channels in device where you can basically have all the pipes produced by lithography, and you can have a chamber maybe say between 10 and 100 microns in volume, and we slot them all together like Lego, and we can make an origin of life system. And I could never get it to work. And I realized I had to do chemistry at the kind of test tube level. And what you want to be able to do, it goes back to that tweet, 1981.
In 1981, the Computer, we're looking at a tweet from Lee. In 1981, the Computer was a distant dream. Oh, wow, this is the scientist looking back at the young boy who dreamed. In 2018, it was realized, spelled in a British way, realized.
I'm starting
which is the wrong
Z, but not.
So now there's a system that does the physical manifestation or whatever the programming language, the spec tells you to do.
Yeah, well, in 1981, I got my first computer, ZX81.
What was the computer?
ZX81.
ZX81.
Sinclair ZX81. It was, and I got a chemistry set, and I like the chemistry set. and I like the computer, and I just wanted to put them together. I thought, wouldn't it be cool if I could use the computer to control the chemistry set? And obviously that was insane. And I was like, 8 years old, right? 9 years old, going on 9 years old, and then I invented the computer just because I wanted to build this origin of life grid, right? Which is like literally a billion test tubes connected together in real time and real space, basically throwing a chemical dice, throw dice. You're going to get lucky. And that's what I think Sara and I have been thinking very deeply about, because, there's more money being spent on the origin of the gravity, or looking at the Higgs boson, than the origin of life, right? And the origin of life is I think the biggest question, or not the biggest question. It is a big question. Let's put it that way.
It is the biggest question. You're okay saying that.
Okay,
Well,
all right.
isn't it possible, once you figure out the origin of life, that's not going to solve, that's not actually going to solve the question of what is life? Like, isn't, because you're kind of putting a lot of,
yeah, I think they're the same problem.
but you're putting, is it possible that you're putting too much bets into this origin part? Maybe the origin thing isn't there always a turtle underneath the turtle? Isn't it a stack of turtles? Because then if you create it in the lab, maybe you need some other stuff.
Well, let's not think about the origin.
Like you like in the lab, there's still memory.
Yeah. Yes.
Right.
The experiment is already the product of evolution.
Right. In some maybe really deep way, not an obvious way, in some very deep way.
Yeah.
So maybe the haters are always going to be like, well, you have to reconstruct you have to build it from scratch.
Fortunately for us, the haters are not aware of that argument.
Well, no, I know. We're
the one making that argument usually, but yeah.
I just think that if we create life in the lab, it's not obvious that you'll get to the deep understanding of necessarily what is the line between life and non-life.
No, I think so. There's so much here.
I'm just like playing devil's
advocate. So much here, but let me play devil's advocate back in a previous conversation, right? And say, yeah, I will. Why not? Yeah, we've got time.
Let's go.
Cellular automata.
Yes.
Cellular automata, these very, very simple things where you color squares black or white and implement rules and play them in time, and you can get these very, very complex patterns coming out. There's nice rules. There are Turing complete rules, and I would argue that cellular automata don't really exist on their own. They have to exist in a computing device. Whether it's computing device is a piece of paper, an abstraction, a mathematician drawing a grid, or a framework. Now, so I would argue CAs are beautiful things, simple, going complex, but the complexity is all borrowed from the lithography, the numbers. Right. Now let's take that same argument with the chemistry experiment origin of life. What you need to be able to do is go out, and I'm inspired to do this, to go out and look for CAs that occur in nature. Let's find some CAs that just emerge in our universe. And
for people, just sorry to interrupt, for people just listening, and in general, I think what we're looking at is a cellular automata where, again, as Lee described, there is just binary black or white squares, and they only have local information, and they're born and they die, and you would think nothing interesting would emerge, but actually what we're looking at is something that I believe is called glider guns. Or a glider gun, which is moving objects in this multi-cell space that look like they're organisms, that have much more information, that have much more complexity than the individual building components. In fact, look like they have a long-term memory, while the individual components don't seem like they have any memory at all.
Yes,
which is fascinating.
The argument here is that has to exist on all this layer of infrastructure, right? And though it looks simple. And then the argument I would make if I were you, say, well, I think CAs are really simple and everywhere, is say, show me how they emerge in a substrate. Now let's go to the origin of life, or machine. I don't think we want to do the origin of life. Just any origin is good. So what we do is we literally have our sand shaker, shake the sand, like massive grid of chemistry experiments, shaking sand, shaking whatever. And then because we know what we've put in, so we know how we've cheated. In the same way with CA, we know how we've cheated. We know we know the number of operations needed. We know how big a grid we want to get this. If we could then say, okay, how can we generate this recipe in the lab and make a life form? What contingency did we need to put in? And we're upfront about how we cheated. Okay, say, oh, you had to shake it. Was it periodic? Planet rotates. It's tried, comes in and out. So, and then we can start to basically say, okay, how difficult is it for these features to be found? And then we can look for exoplanets and other features. So I think Sarah's absolutely right. We want to explain to people we're cheating. In fact, we have to cheat. No one has given, I'm good at writing grants, or I used to be. I'm not very good right now, I keep getting rejected. But writing a grant for a planet in 100 million years, no grant funder is going to give me that. But maybe money to make a kind of a grid, a computer grid, origin of life computer grid. In physical space, and just do it.
So Sara said something, which is you can't simulate the origin of life in a computer. So like in simulation, why not? What are your? Because you said it very confidently. So
yeah,
is it possible? And why would it be very difficult? Like, what's your intuition there?
I think it's very difficult right now because we don't know the physics. But if you go based on principles of assembly theory and you think every molecule is actually a very large causal graph, not just the molecule, then you have to simulate all the features of those causal graphs. And I think it becomes computationally intractable. You might as well just build the experiment.
Because you have, in the physical space, you have all the objects with all the memories.
Yes.
And in the computer, you would have to
yes.
copy them and reconstruct them.
Yes.
Yeah. That's a beautifully put. And I would say that lots of people, you just don't have enough resource. It's easier to actually do the physical experiment because we are literally. I would view the physical experiment almost like a computational experiment. We're just outsourcing. It's just basically we're just outsourcing all the matrix.
And
algebra.
On your point about the experiment being also an example of life, it's almost like you want to design. It's like all of us are. Lineages of propagating information across time. And so everything we do becomes part of life because it's part of that causal chain. So it's like you want to try to pinch off as much as you can of the information from your causal chain that goes into the experiment, but you can't pinch off all of it to move it to like a different timeline. It's always going to be part of your timeline. But at least if you can control how much information you put in, you can try to see how much does that particular trajectory you set up start generating its own assembly. So you know where it starts, and then you want to try to see it take off on its own when you try to pinch it off as much as possible.
Got it. Quick pause, bathroom break.
Yes.
All right, cool. And now we're back. All right. We talked about the early days of the universe when there was just stuff and no memory, not even causality. I think Lee at least implied that causality is emergent somehow. We could discuss this. What happened before this all originated? What's outside the universe?
Divided by zero.
Okay, so it's not relevant, not understandable. Is it useful to even ask the question?
No.
Because it's so hard?
No, it's not hard. It's just not a question. If I can't do an experiment or even think of an experiment, the question doesn't exist.
Well, no, you can't think of a lot of experiments. No offense.
What I mean is if I can't...
Because your causality graph is like, this is what we've been talking about. It's like, there is limits to your ability to construct experiments.
I agree, but I was trying to be facetious, and I'm trying to make a point. Is I think that if there is a causal bottleneck through which information can't propagate in principle, then it's very hard to think of an experiment, even in principle, even one that's beyond my mediocre intellect, right? Which is fine. I'm happy to accept that. But this is one of the things I actually do think there was something before the Big Bang, because I would say that I think the Big Bang just couldn't occur and create time. Time created the Big Bang. But
so there was time before the Big Bang.
Yeah.
There was no space, but there was time.
Yeah. Yeah. But I mean, I'm just making that stuff up just to make all the physicists happy. But I think do
you think that would make them happy? Because they would be quite upset, actually.
Why would they be upset?
Because they would say that time can't exist before the Big
Yeah, I
Bang.
mean, this goes back to an argument that you might not want to have the argument here. I I was talking to Sarah earlier today about an argument we had about time a long time ago,
Yeah.
a long time in time, and what I would is like I think there is this thing called time or state creation. The universe is creating states, and it's outside of space, but they create space. So what I mean is, you can imagine there are states being created all the time, and there is this thing called time. Time is a clock, which you can use to measure when things happen. But that doesn't mean, because you can't measure something, that states aren't being created. And so you might locally refer to the Big Bang, and the Big Bang occurred at some point in when those states were there. Probably there had to be enough states for the Big Bang to occur. And then, but I think that there is something wrong with our conception of how the universe was created and the Big Bang, because we don't really get time. Because again, I don't want to become boring and sound like a broken record, but time is a real thing. And until I can really explain that more elegantly, I'm just going to get into more trouble.
Well, we're going to talk about time because time is a useful measuring device for experiments, but also time is an idea. All that. Okay, but let me first ask Sarah: is like, what do you think? Is it a useful question to ask what happened before the Big Bang? Is it a useful question to ask what's outside the universe?
So I would think about it as the Big Bang is an event that we reconstructed as probably happening in the past of our universe based on current observational data. And so the way I like to think about it is we exist locally in something called a universe. So and going back to like the physics of existence, we exist locally in the space of all things that could exist, and we can infer certain properties of the structure of where we exist locally. And one of the properties that we've inferred in the past is that there is a thing we call the Big Bang. There's some signatures of our local environment that indicate that there was a very low information event that started our universe. I think that's actually just an artifact of the structure of the assembly space, that when you start losing all the memory in the objects, it looks like what we call a Big Bang. So I think it makes sense to talk about where you are locally. I think it makes sense to talk about counterfactual possibilities, what could exist outside the universe, in the sense that they become part of our reasoning and therefore part of our causal chain of things that we can do. So like the multiverse in my mind exists, but it doesn't exist as a multiverse of possible universes. It exists as an idea in our minds that allows us to reason about how physics works, and then to do physics differently because we reason about it that way. So I always like to recenter it on things exist, but they don't always exist like we think they exist. So when we're thinking about things outside the universe, they absolutely exist because we're thinking about them, but they don't look like the projections in our mind. They're something else.
And something you said just gave me an idea to go back to your question. If there was if something caused the Big Bang, if there was some memory or some artifact of that, then of course to answer your question, it's worth going back to that, because that would imply there is something beyond that barrier, that filter.
Yeah.
And that's what you were saying, I guess, right?
I'm agnostic to what exists outside the universe. I just don't think that, I think the most interesting things for us to be doing are finding explanations that allow us to do more, like that optimism. So I tend to draw the boundary on questions I ask as being scientific ones, because I find that that's where the most creative potential is to impact the future trajectory of what we're doing on this planet.
It's interesting to think about the Big Bang is basically from our current perspective of what we're able to detect. It's the time when things were forgotten.
Yes.
It's the time of the reset
Mm-hmm.
from our limited perspective. And so the question is it useful to ever study the thing that was forgotten? Or should we focus just on the memories that are still there?
Well, the point I was trying to make about the experiment is I was trying to say both things. And I think perhaps, yes, from the following point of view, if you could then imagine what was forgotten and then work forwards, you will have different consequences. So then it becomes testable. So as long as we can find tests, and it's definitely worth thinking about. What I don't like is when physicists say what happened before the Big Bang and before, without giving me any credible conjecture about how would we know the difference. But the way you framed it is quite nice. I like that. It's like what have we forgotten?
Is there room for God in assembly theory? Who's God?
I like arguments for a necessary being better than God.
Well, I think
What's
I
a
said it
necessary
earlier.
being? What's a
Like
necessary?
something that has to exist.
Oh, so you like? I mean, you like the shortest path. Like, does God need?
No. I mean, well, you can go back to like Thomas Aquinas and arguments for the existence of God, but I think most of the interesting theological arguments are always about whether something has to exist or there was a first thing that had to exist. But I think there's a lot of logical loopholes in those kind of arguments.
Well, so God here meaning the machine that creates, that generates the stuff.
But God, so what I was trying to say earlier is
Isn't that just the universe, though?
yeah.
Well, yeah. Well, but there's a difference between I imagine like a black box, like a machine.
Yeah.
Then I would be more comfortable calling that God, because it's a machine. You go into a room and there's a thing with a button.
Yeah, I don't like the Great Programmer in the Sky version.
Can I?
Yeah, but if it's more kind of like, I don't like to think of, if you look at a cellular automata, if it's the cells and the rules, that doesn't feel like God that generates a bunch of stuff. But if there's a machine like that runs the cellular automata and set the rules, then that feels like God. That the other sort of, in terms of terminology. So I wonder if there's like a machine that's required to generate this universe. That's very sort of important for running this in the lab.
So as I said earlier, I think I said this earlier, that I can't remember the phrase, but something like, I mean, does God exist in our universe? Yes. Where does God exist? God at least exists in the abstraction in our minds,
Right.
particularly of people who have religious faith they believe in. But let's then take but you're talking a little bit more about generic. Say, well, is there a mechanism beyond the universe you're calling God? I would say God did not exist at the beginning, but he or she does now. Because I'm saying the mechanism.
Well, you don't know if he didn't exist in the beginning. So like this could be us in our minds trying to like just listening to gravitational waves, detecting gravitational waves. It's the same thing. It's us trying to go back further and further into our memories to try to understand the machines that make up us. And so it's possible that we're trying to grasp at possible kind of what kind of machines could create. There's always a tweet. There's always a tweet. If the universe is a computer, then God must have built it because computers need creators. There you go. Mm-hmm. And then Yoshabach replied, since there's something rather than nothing, perhaps existence is the default. If existence is the default, then many computers exist. Creator gods are necessarily computers too. I'm very confused by that. But that's an interesting idea, that existence is the default versus non-existence.
I agree with that, but the rest is not.
Lee responds, perhaps this reasoning is incomplete. That's how scientists talk trash each other on Twitter, apparently. Which part don't you agree with?
When he said if existence is default, then many computers exist. This comes back to the inventor and discovery argument. I would say the universe at the beginning wasn't capable of computation because there wasn't enough technology, enough states. So what you're saying is if God is a mechanism, so I might actually agree, but then the thing is, lots of people see God as more than a mechanism. For me, God could be the causal graph in assembly theory that creates all the stuff and the memories we know. And the fact that we can even relate to each other is because we share that heritage. And why we love each other or we like to see God in each other it's just we know we have a shared existence.
So if the God is the mechanism that created this whole thing, I think a lot of people see God, in a religious sense, as that mechanism also being able to communicate with the objects it creates. And if it's just the mechanism, it won't be able to communicate with the objects it creates. It can only create. It can't interact with the.
Well, there's versions of God that create the universe and then left.
Yeah, like spark
for some religions, but
the first spark. Yeah.
Yeah, but I think I liked your analogy of the machine and the rules, right? But I think part of the problem is we have this conception that we can disentangle the rules from the physical substrate, right? And that's the whole thing about like software and hardware being separate, or the way Newton wrote his laws, that there was some, like they exist outside the universe. They're not actually a feature of the universe. They don't have to merge out of the universe itself. So I think if you merged your two views, then it gets back to the God as the universe. And then I think the deeper question is, why does it seem like there's meaning and purpose? And if I think about the features of the universe that give it the most meaning and purpose, those are the what we would call the living components of the universe. So if you wanted to say God is a physically real thing, which you were saying is like an emergent property of our minds, but I would just say, the way the universe creates meaning and purpose, there is really a physics there. It's not like a illusory thing, and that is just what the physics of life is.
So is it possible that we've forgotten much of the mechanisms that created the universe?
Mm-hmm.
So so basically, whatever, if God is that mechanism, we just leave parts of that behind.
Well, but the universe is constantly generating itself. So if God is that mechanism, it would be that would still be active today. I don't believe.
Right.
I'm agnostic, but if I would call the things I believe in God in the way that some people talk about God, I would say that God is, like in the universe now. It's not an absent thing.
I think there's a mislabeling here, because I'm a professional idiot, actually, but
you should put that on your CV.
Yeah.
Yeah.
Professionally,
but
not recreationally or amateur, but professionally. I think for it.
I would say if you were talking about God, again, I'm way out of my depth here, and I almost feel uncomfortable. Oh. Yeah, but I feel quite uncomfortable articulating, but I'll try. For me, a lot of people that think of God as a consciousness, a reasoning entity that actually has causal power, and you're
human-like intelligence.
And so you're like, then you're saying like gravity could be God or time could be God. I think for me, from my conception of time, is probably as fundamental as God, because it gave rise to human intelligence and consciousness, in which we can have this abstract notion of God. So I think that you're maybe talking about God in a very mechanistic, kind of unsophisticated sense, whereas other people say that God is more sophisticated and got all this, feelings and love and, and this abstracting ability. So is that what, or do you mean that? Do you mean God as in this conscious entity that decided to flick the universe into existence?
Well, one of the features that God would have is the ability to flick the universe into existence. Like Windows 95. I don't know if God is Windows 95 or Windows XP or Windows 10. I don't know the full feature set.
Okay.
So at the very least, you have to flick the universe into existence. And then other features might include ability to interact with that universe in interesting ways. Okay. And then how do you interact with the universe in interesting ways? You have to be able to speak the language of its different components. So in order to interact with humans, you have to know how to act human-like. Mm-hmm. So I don't know, but it seems like whatever mechanism created the universe might want to also generate local pockets of mechanisms that can interact with that. Like
could make a joke.
Inject.
Like God was lonely?
Yeah, it was lonely. It could be just a teenager and another just playing a video game.
Yeah, maybe. Well, I was going to say, I don't, so this is referring to our Origin of Life engine. It's like, I don't believe in God, but that doesn't mean I don't want to be one.
Right.
Because I want to make a universe and make a life form, but that may be rude to people who have, dear religious beliefs. What I mean by that is, isn't it, if we are able to create an entirely new life form, different chemistry, different culture, what does it makes us good? By that definition, it makes us gods, right?
Well, there is. Like when you have children, you're like, one of the magical things of that is you're kind of mini gods. First of all, from a child's perspective, parents are gods for quite a while. And then they're in the positive sense. There's a magic to that. That's why I love robotics. Is you instill life into something, and that makes you feel godlike in a sort of positive way.
Being
like
a creator is a positive
creator.
feeling. Yeah.
Yeah, exactly.
Yeah.
And a small scale, and then God would be a creator at the largest possible scale, I suppose. Okay, you mentioned offline the Assemblytron. Assemblytron.
Yep.
What's an Assemblytron? This is an early idea of something you're thinking about.
So Sarah's team. I think Sarah's team are interested in using AI to understand life. My team is, and I'm wondering if we could apply the principles of assembly theory, that is, the causal structure that you get with assembly theory, and hybridize it and make a new type of neuron, if you like. I mean, there are causal neural networks out there, but they are not quite the architecture like what I would like. I would like to associate memory bits with basically I'd like to make rather than having an ASIC for neural networks, I want to make an ASIC for assembly networks, right? And
so can you say that again? Assembly networks. So what is like a thing with an input and output, and it's like a neural network type of thing. What does it do exactly? What's the input? What's the output?
So in this case, so if you're talking about a general neural network, I mean, in general neural network, you can train it on any sort of data, right? Depending on the framework, whether it's like text or image data or whatnot, and that's fine. But there's no causal structure associated with that data. Now, just imagine, rather than, let's say we're going to classify a difference between cat and dog, right? Classic cat and dog neural network. What about if the system understood the assembly space that created the cat and the dog? And rather than guessing what was happening and training on those images and not understanding those features, you almost like you could imagine doing going back a step and doing and training, going back a step and doing the training, going back a step, and I wonder if that is actually the origin of intelligence, or how we'll crack intelligence, because we'll create the entire graph of events and be able to kind of look at cause and effect across those graphs. I'm explaining it really badly, but it's a gene of an idea, and I'm guessing very smart, very rich people in AI are already doing this.
Trying to not generate cats and dogs, but trying to generate things of high assembly index.
Yeah, and I think and also using causal graphs in neural networks and machine learning and deep learning, maybe building a new architecture. I'm just wondering, is there something we can get out of assembly theory that allows us to rebuild current machine learning architectures to give causation more cheaply? I mean, I don't know if that's what we've been inventing this for a little while, but we're trying to finish the theory paper first before we do anything else.
Yeah, you also want to have, say, goal-directed behavior in neural networks. Then assembly theory is a good framework for doing that. Daniel's been thinking about that a lot.
Yeah.
And I think it's a really interesting idea that you can map concepts from how neural networks learn to thinking about goal-directed behavior as a learning process, that you're learning a specific goal. The universe is learning a goal when it generates a particular structure, and that you can map that physical structure into a neural network.
What's the goal?
Well, in a neural network, you're designing the goal. In biology, I mean, people are not supposed to use teleological language in biology, which is ridiculous, but because goals are real things, they're just post-selected. So you can talk about goals after the fact. Once a goal emerges in the universe, that physical entity has a goal. But Lee and I came up with a test for, like a Turing test for goal-directed behavior, based on the idea of assembly. We have to formalize this still, but I would like to write a paper on it. But the basic idea is if you had two systems that were completely equivalent, in the instantaneous, physical experimental setup. So Lee has to figure out how to do this. But there was something that would be different in their future. and there was a symmetry breaking you observe in the present based on that possibility, that future outcome, then you could say that that system had some representation of some kind of goal in mind about what it wanted to do in the future. So goals are interesting because they don't exist as instantaneous things. They exist across time, which is one of the reasons that assembly theories may be more naturally able to account for the existence of goals.
So goals are they only exist in time, or they manifest themselves in time through you said symmetry breaking.
So it's almost like, imagine like if representations in your mind are real, right? And you can imagine future possibilities, but imagine everything else is physically equivalent. And the only thing that you actually change your decision based on is what you model as being the future outcome. Then somehow that representation in your mind of the future outcome becomes causal to what you're doing now. So there's kind of like retrocausal effect, but it's not actually retrocausal. It's just that your assembly space is actually includes those possibilities as part of the structure. It's just you're not observing all the features of the assembly space in the current moment.
Well, the possibilities exist, but they don't become a goal until they're realized.
So one of the features of assembly space that's super interesting, and it's easier to envision with like Legos, for example, is if you're thinking about an assembly space, you can't observe the entire assembly space in any instant in time. So if you imagine a stack of Legos and you want to look at the assembly space of a stack of Legos, you have to break the Legos apart. And then you look at all the possible ways of building up the original object. So now you have in your mind the goal of building that object, and you have all the possible ways of doing it. And those are actual physical features of that object, but that object doesn't always exist. What exists is the possibility of generating it.
Right. And the possibilities are always infinite.
Well, for that particular object, it has a well-defined assembly space. And I guess what I'm saying is that object is the assembly space, but you actually have to unpack that object across time to view that feature of it. It's only an observable across time.
The term goal is such a important and difficult to explain concept, right? Because what you want is like, I think only conscious beings can have conscious goals. Everything else is doing selection. But selection does invent goals, and in a way that the way that biology reinterprets the past in the present is kind of how it allows you to understand there was a goal in the past now, right? It's kind of like goals only exist back in time.
So, first of all, only conscious beings can have conscious goals. I'm not even going to touch that one.
Why?
Well,
go for it. Come on.
What the line between conscious goals and non-conscious goals exactly? All right, and also maybe just on top of that, you said a Turing test for goal-directed behavior. What does a Turing test potentially look like?
So if you've got two objects, we were thinking about this. So we actually got some funding to work together on two teams. So I'm trying to do, and part of this is I'm trying to do a bit of theory, and Sarah's teaching me a bit of theory. And Sarah's trying to design experiments, and I'm teaching experiments because I think it's really good for us to have that. To say, when would so that's good. I like this. Should we use the Dan Dennett essay that he wrote on?
And I can explain why we wouldn't want to call it a Turing test after. But
So Dan Dennett wrote this really nice essay about herding cats and free will inflation.
Love the title. The title is so brilliant.
I think that's the actual title.
I think
the
so.
Title, yeah.
Herding cats and free will inflation.
Mm-hmm.
Yeah, something like that. I mean, it's maybe not. And so,
no, I think that's right.
So if you've got let's imagine you've got two objects on a hillside, okay, and it just happens to be a snowy hill, and let's just say you see an object go rolling down the hill, or you and the rock rolls down the hill at the start, goes to the end. How do you know that object's had a goal? Now you unveil the object and you'll see it's actually a skier. And the skier starts at the top and goes down the bottom. Great. Then you look at the rock. Rock rolls down the hill, gets to the bottom. How can you tell the difference between the two? So, and what Dan says is like, well, it's clear the skier's in control. and because they're adjusting trajectory, so there's some updating going on. Then the only way you could really do that is you put the skier back to the top of the hill again. They would tend to start roughly in the same space and probably take all that complex set of trajectories and end up pretty much at the same finish point, right? With plus or minus a few meters. Whereas if it's just a random rock going down random trajectory, that wouldn't happen. And so what Sarah and I were kind of doing when we were writing this grant, we were like, we need to somehow instantiate the skier and the rock in an experiment, and then say, okay, when does the object, for an object to have a goal, it has to have an update, it has to have some sensing and some kind of, inbuilt actuation to respond to the environment. And then we just have to iterate on that. And maybe, Sarah, you can then fill in the Turing test part.
Well, yeah, I guess the motivation for me was slightly different. So I get really frustrated about conversations about consciousness, as most people do. And a lot of people are which is not necessarily related to free will directly or to this goal-directed behavior, but I think there's a whole set of bundled and related topics here. But I think for me, I was, everybody's always interested in explaining intrinsic experience and quantifying intrinsic experience. And there's all sorts of problems with that because you can never actually be another physical system. So you can't know what it's like to be another physical system. So I always thought there must be some way of getting at this problem about if an agent or an entity is conscious or at least has internal representations, and those are real physical things, that it must have causal consequences. So the way I would ask the question of consciousness is not, what is it like intrinsically, but if things have intrinsic experience, is there any observable difference from the outside about the kind of causation that physical system would enact in? And for me, the most interesting thing that humans do is have imagination. So like we can imagine rockets centuries before we build them. They've become real physical things because we imagine them. And people might disentangle that from conscious experience, but I think a lot of the sort of imagination we do is actually a conscious process. So then this becomes a question of if I were observing systems and I said one had an internal representation, which is slightly different than a conscious experience, obviously. So I'm entangling some concepts, but it's a loose set of thought experiments. Then I set them up in a physically equivalent situation. Would it be the case that there would be experimental observables associated with it? And that became the idea of trying to actually measure for internal representation of consciousness. So Turing basically didn't want to do that. You just wanted the machine that could emulate and trick you into having the behavior, but never dealt with the internal experience because he didn't know how to do that. And I guess I was wondering, is there a way to set up the experiment where you could actually test for that?
For imagination that led to
that there was something internal going on, some kind of inner world, as people say. But or you could say, like it actually is an agent. It's making decisions. It has an internal representation. And whether you say that's experience or not is a different thing. But at least the feature that there's some abstraction it's doing that's not obvious from looking at the physical substrates.
Do you think it's possible to do that kind of thing? One of the compelling things about the Turing test is that, defining intelligence, defining any complicated concept as a thing, like observing it from the surface and not caring about what's going on deep inside, because how do you know?
That's the point. So the idea is exactly that. So what we're trying to do, the Turing test for goal-directedness, is literally take some objects that clearly don't have any internal representation, grains of sand blowing on the beach or something, right? And, I don't know, a crab wandering around on the beach. And then generating an experiment where the experiment generates an entity that literally has no internal representation to sand. These are oil droplets, actually, what I've got in mind, a robot that makes oil droplets. But then what we want to try and do is train the oil droplets to be like crabs. Give them an internal representation. Yeah. Give them the ability to integrate information from the environment so they remember the past, are in the present, and can imagine a future. And in a very limited way, their kind of game engine, their limited simulation of the world allows them to then make a decision.
They're objects across time.
So then you would run a bunch of crabs, like over and over and over and over?
How many crabs, Lee?
How many is there? What's because you have to have a large number of crabs. What does your
don't-
theory say? Is there a mathematical
We're working on it. I mean, this is literally
limit? Crab limit.
There's literally a
Excellent.
there's literally
What's the herding cats have to do? Oh, that's random. Wait, what's cats in the title by Daniel Dennett? Herding cats and the free will inflation.
so I
What
love
does
this.
herding cats mean? What does free will inflation mean?
So I love this essay because it explained to me how I could live in a deterministic universe, but have not free will, but have freedom. And also it helped me explain that time needed to be a real thing in this universe. So what basically Dan was saying here is like, how do these cats appear to just do what they want, right? And if you live in a deterministic universe, why do the cats do these things? Aren't they just? Isn't it all obvious? And how does free will inflate the universe? And for me, I mean, probably I love the essay because my interpretation of the essay in assembly theory makes complete sense. Because you need an expanding universe in assembly theory to create novelty that you search for, that then when you find something interesting and you keep doing it because it's cool and it gives you an advantage, then it appears in the past to be a goal.
So what does in assembly theory the expansion of the universe look like? What are we talking about? Why does the expansion of the universe give you more possibilities of novelty and cool stuff?
So for me, I don't think about the universe in terms of Big Bang and space. I think about it in terms of the big memory expansion. That you only have the ability to store one bit of information, so then you can't do very much. So what the universe has been doing since forever, it's been creating more. It's been increasing the size of its RAM. Okay, so it's like 1 megabyte, 2 megabyte, 3 megabyte, 4 megabytes, all the way up. And so the more RAM you have, the more you can remember about the past, which allows you to do cooler things in the future. So if you can remember how to launch a rocket, then you might be able to imagine how to land a rocket and then relaunch, reland, and carry on. And so you're able to expand the space and remember the past. And so that's why I think it's very important.
But not a perfect memory. It's an interesting question whether there's some forgetting that happens that might increase. Is the expansion of the forgetting at some point accelerate faster than the remembering?
I think that's a very important thing that probably intelligence does, and we're going to learn in machine learning about, because you want machine learning right now or artificial intelligence right now doesn't have memory, right? But you want the ability to, or not for, if you want to get to human-like consciousness, you need to have the ability, I suppose, to remember stuff and then to selectively forget stuff so you can re-remember it and compress it. Arguably, the way that we come up with new physical laws.
Cryptocurrency.
Yeah, yeah. Sorry, you were confirmed.
No, it's all right. No, I just wanted to.
I think that there is a great deal to be gained from having the ability to remember things, but then when you forget them, you can then you can basically do the simulation again and work out if you get to that compressed representation. So that it's in cycles. So cycles of remembering and forgetting are probably important, but there shouldn't be an excuse to have a universe with no memory in it. The universe is going to remember that it forgot, but just not tell you.
I'm looking at this paper, and it's talking about a puppet controlling 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 a puppet. Conceptually easy to understand, but physically impossible. As physically impossible as predicting a fair coin toss. I don't know what he's talking about, but there's pictures of puppets controlling puppets. Let me ask you. There's a few things I want to ask, but we brought up time quite a bit. You guys tweet about time quite a bit. What is time in all of this? We kind of mentioned it a bunch. Is it not important at all in terms of, is it just a word? Should we be talking about causality mostly? Like, Sarah, what do you think? We've talked about like memories. Is that the fundamental thing that we should be thinking about? And time is just a useful measurement device or something like that?
Well, there's different concepts of time, right? So I think in assembly theory, when we're talking about time, we're talking about the ordering of things. So that's the causal graph part. And so then the fundamental structure of the universe is that there is a certain ordering. and certain things can't happen until other things happen. But usually when we colloquially talk about time, we're talking about the flow of time. And I guess Lee and I were actually debating about this morning. So, and talking on it, walking on the river here, which is a very lovely spot for talking about time. But that when the universe is updating, it's transitioning between things that exist now and things that exist now. That's really the flow of time. So there's you have to separate out those concepts at bare minimum. And then there's also an arrow of time that people talk about in physics, which is that time doesn't appear to have a directionality in fundamental physics, but it does to us, right? Like we can't go backwards in time. And usually that would be explained in physics in terms of, there's a cosmological arrow of time, but there's also the thermodynamic arrow of time of increasing entropy. But what we would say in assembly theory is that there is a clear directionality. The universe only runs in one direction, which is why it's easy to make, if the universe runs in one direction, it's easy to make processes look reversible. For example, if they have no memory, they're easy to run forward and backwards, which is why the laws of physics that we have now look the way they do, because they involve objects that have no memory. But when you get to things like us, it becomes very clear that the universe has a directionality associated to it.
So it's not reversible at all. It's the no man ever steps in the same river. I just have to bring that up because you walk on the river. No man ever steps in the same river twice, for it's not the same river and he's not the same man. It's not reversible. Any of the same.
No, but reversibility is an emergent property, right? So we think of the reversibility of laws as being fundamental and the irreversibility as being emergent. But I think what we would say from how we think about it, and it certainly seems to be the case for our perception of time, but also, what's happening in biological evolution, you can make things reversible, but it requires work to do it. And it requires certain machines to run it forward and backward. And Chiara Marletto is working on some interesting ideas on constructor theory related to that, which is a totally different set of ideas. And
so you can travel back in time sometimes.
Yes. You could you can't travel actually back in time, but you could reconstruct
you travel
things
forward
that have
in time.
existed in the past. You're always moving forward in time, but you can cycle through. Like I
clarify what you just said?
Yeah, go for it.
Quickly, you travel forward in time to travel back.
Yes.
Thank you. That really clarifies.
Well, no, what Sarah's saying is you don't go back in time. You recreate what happened in the past in the future and inspect it again.
So in that local pocket of time, it's as if you travel back in time. So I don't. How's that not traveling back in time?
Because you're not going back to your same self back in time. You're creating that in the future.
Everything else is the same as it was in the past.
No. It's not in registry. I mean, it goes back to the big question. I'm saying, this is something I was trying to look up today when we first had this discussion, and I was talking to Sara on Skype, and I said, by the way, time is the fundamental thing in the universe. And she almost hung up on me.
Right, but you can even, if you want to make an analogy to computation, and I think Charles Bennett actually has a paper on this, like about reversible computation and reversible Turing machines. In order to make it reversible, you have to store memory to run the process backwards. So time is always running forward in that. So because you have to write the memory.
You can't erase the memory.
You can erase the memory, but the point, when you go back to zero, right? But the whole point is that in order to have a process that even runs in both directions, you have to start talking about memory to store the information to run it backwards.
I got it. So you can't really you can't have it exactly how it was in the past.
Yeah, exactly. So
you have extra stuff, extra baggage always. Okay.
A really important thing that I want to say on this, I think if I try and get it right, is to say that if you can think that the universe is expanding in terms of the number of boxes that it has to store states, right? And this is where the directionality of the universe comes from. Everything comes from. You could erase what's in those boxes, but the fact you've now got so many boxes now in this present, there's more of those boxes than there were in the past.
See, but the boxes aren't physical boxes. They're not space. It's not space or time. So why is the number of boxes always expanding?
It's very hard to imagine this because we live in space.
Yeah.
So what I'm saying, which is I think probably correct, is that let's just imagine for a second, there is a non-local situation, but there are these things called states, and that the universe, irrespective of whether you measure anything, there is a universal, let's call it a clock or a state creator, Maybe we can call it, that's why maybe you can call it God, but let's call it a state creator where the universe is expanding in the number of states it has.
Why are you saying it's expanding though? Is that obvious that it's expanding?
It's
in the
obvious
number of
because
states?
that's where
That's a source of novelty.
it's a source of novelty, and it also explains why the universe is not predictable.
How do you know it's not predictable?
Well,
I just like interrupting you. Sorry, it's fun. 'Cause you're struggling.
I'm struggling because I'm trying to be as concrete as possible and not sound like I'm insane.
Yeah.
And I'm not insane. It's obvious because I'm a chemist, so as a chemist, I grew into the world understanding irreversibility. Irreversibility is all I knew. And when people start telling me the universe is actually reversible, it's a magic trick. We can use time to do it. So what I mean is the second law is really the magical. But why does it need to be magical? The universe is just asymmetric. All I'm saying is the universe is asymmetric in the state production, and we can erase those states, but we just have more computational power. So what I'm saying is that the universe's deterministic horizon, this is one of the reasons we can't live in a simulation, by the way. You can't live in a simulation.
The irreversibility?
Yeah. So basically, every time you try and simulate the universe, I live in a simulation, the universe is expanded in states. You're like, oh, damn it, I need to make my computer bigger again. And every time you try and contain the universe in the computation, because it's got bigger in number of states. And so I'm saying the fact the universe has novelty in it is going to turn out experimentally to be proof that time, as I've labeled it, is fundamental and exists as a physical thing that creates space.
Okay, so if you can prove that novelty is always being created, you're saying that it's possible to also then prove that it's always expanding in the state space. Those are things that have to be proven.
That's what we're working on experiments for, yeah.
And you're trying to, like, by looking at the sliver of reality, show that there's always novelty being generated.
Yeah. Because if we go and live in a universe that the conventional physicist would live in, it's a big lookup table of stuff and everything exists. I want to prove that book doesn't exist. It's continuously being added pages on. So all I'm saying, if the universe is a book, we started the universe at the beginning only had no pages and had one page, another page, whereas a physicist would now say all the pages exist and we could in principle access them. I'm saying that is fundamentally incorrect.
Do you know what's written in this book, The Free Will Question? Is there room for free will in this in this view of the universe is generating novelty and getting greater and greater assembly structures built? Sarah?
Yes.
Okay.
Done. Next question.
Why? What's the source of free will in this?
Well, so I think it depends on what you mean by free will. But
yeah, well, please. There's a lot.
I think what I'm interested in, as far as the phenomena of free will, is do we have individual autonomy and agency? And when I do things, is it really me or is it my atoms that did it? And that's the part that's interesting to me. I guess there's also the determinism versus randomness part. But the way I think about it is like each of us are like a thread or like an assembly space through this giant possibility space, and it's like we're moving on our own trajectory through that space, and that is defined by our history. So we're sort of causally contingent on our past, but also because of the sort of intersection of novelty generation, it's not completely predetermined by the past. And so then you have the causal control of the determinism part, that you are your causal history and there's some determinism from that past, but there's also room for creativity. And I think it's actually necessary that something like free will exists if the universe is going to be as creative as possible. Because if I were all intelligent being inventing a universe and I wanted it to have maximal number of interesting things happen, again, we should come up with the metric of interesting. But
Assembly.
generating, yes, I know, generating, maximal possibilities, then I would want the agents to have free will, because it means that they're more individual. Like like each entity actually is a different causal force in the universe, and it's intrinsic and local property of that system.
There's a greater number of distributed agents. Like, are you always creating more and more individuality?
Kind of. I would say you're creating more causal power, but
So causal power, the word consciousness, is the causal power somehow correlated with consciousness?
I mean, that's why I have this conception of consciousness being related to imagination, because the more that we can imagine can happen, and the more counterfactual possibilities you have in mind, the more you can actually implement. And somehow free will is also at the intersection of the counterfactual becoming the actual.
So can you elaborate on that a little bit, that consciousness is imagination?
I don't know exactly how to articulate it, and I'm sure people will take, aim at certain things I'm saying, but I think the language is really imprecise, so I'm not the best way
it's
to.
It's really interesting. Like, what is imagination, and what is it? What role does it play in the human experience, in experience of any agent?
I love imagination. I think it's like the most amazing thing we do. But I guess one way I would think about it is, we talked about the transition to life being the universe acquiring memory, and life does something really interesting. As you think about biology generally, it remembers states of the past to adapt to things that happen in the future. So the longer life has evolved on this planet, the deeper that past is, the more memory we have, the more kinds of organisms and things. But what human level intelligence has done is quite different. It's not just that we remember states that the universe has existed in before, it's that we can imagine ones that have never existed, and we can actually make them come into existence. And I think that's the most unique feature about the transition to whatever we are from what life on this planet has been doing for the last 4 billion years.
And I think
it's deeply related to the phenomena we call consciousness.
Yeah, just agree with that. I think that consciousness is the ability to generate those counterfactuals. Now, whether you can say, are there degrees of consciousness? I'm sorry, panpsychists, but electrons don't have counterfactuals, although they do have some kind of, they are able to search the space and pathways. But I think that there is a very concrete, there's a very specific property that humans have, and I don't know if it's unique to humans. I mean, maybe dogs can do it, and birds can do it, right? And where they are basically solving a problem, because consciousness was invented, or this abstraction was invented by evolution for a specific reason. And so, look, one of the reasons why I came to the conclusion that time was fundamental was actually because Sara and I had completely different.
The most heated debate on Skype chat ever.
No. We had to.
On which topic?
No, it goes back to the free will thing. So I think that, although I've changed my view a bit, because there's some really interesting physicists out there who talks about how the measurement problem in Newtonian space. But I don't want to go there just now because I think I'll mess it up. But briefly, I could not see how how we can have free will. And this is really boring, because this is a well-trodden path. But it's not so boring. I suppose it's kind of, we just want to be precise. If the universe is deterministic, how can we have free will, right? So Sarah's a physicist. I think she can show that most of the laws we have are deterministic to some degree, quantum mechanics onto Newtonian stuff. And yet there's Sara telling me she believes in free will. And I'm like, your belief system is broken here, right? Because you're demanding free will in a deterministic universe, and then I realized that I agreed with her that I do think that free will is a thing, because we are able to search for novelty, and then that's where I came to the conclusion that the universe was expanding in terms of novelty, and it goes back to that Dan Dennett essay that we're talking about, the free will inflation. Yeah. Free will. So so the past, it did not exist in the past. The past exists in the present. What I mean is, like, there was no past. There is only present. So that means you are the sum total of everything that occurs in the past is manifestly here in the present. Yeah. And then you have this little echo state in your consciousness, because you're able to imagine something without actualization, but the fact you imagine it, that occurs in electrons and potassium ion flows in your neural network in your brain.
Maybe consciousness is just the present.
So somehow you imagine that, and then by imagining, oh, that's good, yeah. I'm going to make a robot to do this thing and program it, and then you physically then go and do it. So that then changes the future. Sorry.
What's imagination? Does it require the past? Does it require the future? Does it require memory? Does it?
Yeah. So imagination.
Does it only exist in the moment?
So imagination is, probably it's an instantaneous readout of what's going on. You can maybe your subconscious brain has been generating all the bits for it, but no, imagination occurs when you, in your game engine, you remember the past and you integrate sensory the present, and you try and work out what you want to do in the future, and then you go and make that happen. So the imagination is this. It's like asking what imagination is about, asking what surfing is. You can surfboard, surfer, wave coming in. When you're on that wave and you're surfing, that's where the imagination is.
I think imagination is just accessing things that aren't the present moment in the present moment. So like I'm sitting here and I'm looking at the table and I can imagine the river and things or whatever it was. And so it seems to be that it's like it's our ability to access things that aren't present.
But so conjure up worlds, some of them might be akin to something that happened to you recently.
Right, but they don't have to be things that actually happened in your past. And I think this gets back to assembly theory. Like the way I would think about imagination from an assembly theoretic standpoint is I'm a giant causal graph. And I exist in a present moment as a particular configuration of Sara. But there's a lot of, I carry a lot of evolutionary baggage. I have that whole causal history and I can access parts of it. Now, when you talk about getting to something as complex as us, having as large an assembly space as us, there's ways of, like, there's a lot of things in that causal graph that have ever actually never existed in the past history of the universe, because like the universe got big enough to contain the three of us in this room in time, but not all the features of each one of us individually have come into existence as physical objects we would recognize as individual objects. This goes back to your point that we actually have to explain why things actually even look like objects and aren't just a smear of mess. And just on the free will and physics thing, when you were talking, I just want to bring this up because I think it's a really interesting viewpoint that Nicholas Jizen has, that like we want to use the laws of physics and then say you can't have free will. And his point is you have to have free will in order to even choose to set up an experiment to test the laws of physics. So in some sense, free will should be more fundamental than physics is, because to even do science, there's some assumption that the agents have free will. And I always thought it was really perplexing that physics wants to remove agency, because the idea that I could do an experiment here on this part of Earth and then I can move somewhere else and prepare an identically prepared experiment, run an experiment again, seems to imply something about the structure of our universe that is not encoded in the laws that we're testing in those experiments.
So this kind of dream of physics that you can do multiple experiments, different locations, and then validate each other, you're saying that's an illusion?
No, I'm saying that requires decision-making and free will to be a real thing, I think. Like, I think the fact that we can do science is not arbitrary. And I think people, the standard canon in physics would be, well, you could trace all of that back to the initial condition of the universe. But the whole point of science is I can imagine doing the experiment and I can do it. And then I can do it again and again and again all over the planet.
To you, imagination is somehow fundamentally generative of novelty.
Yes.
So it's not like the universe could have predicted the things you imagined.
Imagination so coming back to novelty, I think novelty can exist outside of imagination, but it supercharges it. It's another transition, I think. I mean, I would say, this may be a boring statement, but I would say sorry?
I'm not sure. These are hard questions.
Yeah, I think the fact that objects exist is yet another proof that time is fundamental and novelty exists, right? Because I think, again, if you ask a physicist to write down an infinite Bible of the universe, let's call it the Bible, the
book.
Yeah, well,
book that we're adding pages
the mathematical universe, whether you're Max Tegmark or Sean Carroll or Frank Wilczek or Stephen Wolfram, okay?
Yeah,
I like that book.
Yeah, I love it too. There's lots of pretty pictures.
It's really interesting that they cope with the enormity of the universe by saying, well, it's all there, mathematics, it all exists, right? And I would say that that's why I'm excited about the future of the universe, because it although it is somehow dependent upon the past, it is not constrained just by the past, which is kind of mad.
Yeah, that's what free will is. It's not constrained by the past. It's dependent on the past. This moment, it's not just dependent. This moment is the past, and yet it has the capacity to generate a totally unpredictable future.
I mean, the other thing I would say is super important for human beings, right? Human beings have actually very little causal control in the future. I realized this the other week.
Oh, the immediate future, you mean?
Yeah. But so what happened? So this is what I think it is. The way, by reinterpreting your past, I mean, talk about from a kind of cognitive, psychological, cognitive point of view, by reinterpreting your past in your current mind, you can actually help you shape your future again. So, you have much more freedom to interpret your past, to act in the present, to change your future than you do to change your future. It may sound weird. So I'm saying to everybody, imagine your past, think about your past, reinterpret your past in the nicest way you can, then imagine what you can do next, or imagine your past in a more negative way and what you do next. And look at those two counterfactuals. They're different.
Yeah, it's fast. I mean, Daniel Kahneman talks about this, that most of our life is lived in our memories. And it's interesting because you can essentially, in imagination, choose the life you live. So maybe free will exists in imagination. Choices are made in your imagination. And that results in you basically able to control how the future unrolls. Because you're like imagining, like reinterpreting constantly the things that happen to you.
Exactly. So if you want to increase your amount of free will, those people that have I don't think everyone has equal amounts of agency because of our sad constraints, whether happenstance, health, economic, born in a certain place, right? But those of us that have the ability to go back and reinterpret our past and use that to change the future are the ones that exert most agency in the present. And I want to achieve higher degrees of agency and enable everyone else to do that as well, to have more fun in the universe.
Then we'll hit that peak.
No,
the maximum fun point.
I don't think there's ever going to be a maximum. I think it's the wonderful thing about the future is there's always going to be more fun.
Yeah, I think, again, going back to Twitter, I think you tweeted something about being a life maximalist, that you want to maximize the number of life, the amount of life in the universe. So, and that's the more general version of that goal, is to maximize the amount of fun in the universe, because life is a subset of fun. There are all kinds of, I suppose they're either correlated or exactly equal. I don't know. Anyway, speaking of fun, let me ask you about alien sightings. So there's been quite a bit of UFO sightings and all that kind of stuff. What do you think would be the first time when humans see aliens in a sort of unquestionable way? This extremely strong and arguable way. We've made contact with aliens. Sara, what would it look like? Obviously, the space of possibilities is huge here, but if you were to kind of look into the future, what would that look like? Would it be inklings of UFOs here and there that slowly unravel a mystery, or would it be like an obvious, overwhelming signal?
So I think we have an obsession with making contact with events. So what do I mean by that is, like people have a UFO sighting, they make contact. And I always think, what's interesting to me about the UFO narratives right now is not that I have a disbelief about what people are experiencing or feeling, but like the discussion right now is sort of at the level of modern mythology. Aliens are our mythos in modern culture. And when you treat it like that, then I want to think about, when do things that we traditionally only regularize through mythology actually become things that become standard knowledge? So, like it used to be, variations in the climate were described by some kind of gods or something. And now it's like, our technology picks up an anomaly or someone sees something, we say it's aliens. And I think the real thing is, it's not contact with events, but like first contact is actually contact with knowledge of the phenomena or the explanation. And so this is very subtle and very abstract, but when does it become something that we actually understand what it is that we're talking about? That's first contact. It's not.
Would you make the myth? Would you give credit to the myth, the mythology as first contact? Because
I think, yes. I think it's the rudimentary that we have some understanding that there's a phenomena that we have to understand and regularize. So I think.
Right, to understand that there is weather.
Yes.
You have to construct a
Yes.
mythology around that
Yes.
weather.
Yes.
It's something that's controllable.
Right.
Yeah, like this is a
I see
phenomenon.
mythology basically as like baby knowledge.
Right.
It could be that, although there's lots of alien so-called alien sightings, right? So there is a number of things you can do. You could just dismiss them and say they're not true, they're kind of made up, or you say, well, there's something interesting here, right? We keep seeing a commonality, right? We see the same phenomena again and again and again. Also, there's this interesting thing about human imagination. Even if they are, let's not say made up, but misappropriated kind of other inputs, the fact that human consciousness is capable of imagining contact with aliens, does that not tell us about something about where we are in our position, in our culture, in our technology?
It tells us about where in time we are.
Could it be that we're making contact with, let's take the most miserable version. There are no aliens in the universe. Life is only on Earth. That then the interpretation of that is we're desperate to kind of understand why we're the only life in the universe, right? The other one is the other most extreme is that aliens are visiting all the time, and we're just not able to capture them coherently, or there's a big conspiracy, and there's Area 51, and there are lizards everywhere, and there's that. Or I'm kind of in favor of the idea that maybe humanity is waking up to the idea that we aren't alone in the universe, and we're just running the simulation, and we're seeing some evidence. We don't know what life is yet. We do have some anomalies out there. We can't explain everything. And over time, we will start to unpack that. One very plausible thing we might do, which might be boring for the average alien observer or believes that aliens are, as in intelligent aliens, are visiting Earth, it could be that we might go to the outer solar system and find a new type of life that has completely new chemistry. Bring these cells back to Earth, where you could say in my hand, on Earth, here's RNA, DNA, and proteins, and look, cells self-replicate. From Titan, we got this new set of molecules, new set of cells, and we feed it stuff and it grows. That, for me, if we were able to do that, would be like the most... That would be my UFO sighting.
That's a good test. So you feed it and it grows.
Yeah.
We've made so not until you know how to feed the thing.
Yeah.
And
it's like
it grows somehow.
We can make a comic book, the tiger that came for tea, the alien that came for tea.
What would you say is between the two of you is the biggest disagreement about aliens, alien life out there? Is it from the basic framework of thinking about what is life to maybe what aliens look like, to alien civilizations, to UFO sightings? Where would you think?
So I would say the biggest one is that the emergence of life does not have to be, it can't just happen once on a planet, that it could be two or more life forms present on a planet at once. And I think Sarah doesn't agree with that.
I think that's like logically inconsistent.
That's really polite. You're saying it's nonsense, but because you think that, yeah.
How likely is that? So the idea that what does it look like? Let's imagine two alien civilizations coexisting on a planet. What's that look like exactly?
So I would say, I think I've got to get around your argument.
Okay.
Yeah, let's say that on this planet, there's just there's lots of available chemistry, and one life form emerges based on carbon and interacts, and there's an ecosystem based on carbon, and there's an orthogonal, and so it's planetary phenomena, which is what I think, right? But there's also one that goes on silicon, and because there's enough energy and there's enough stuff that these life forms might not actually necessarily compete evolutionarily.
Yeah, but they would have to not interact at all because they're going to be co-constructing each other's causal chains.
I think that's where you just got me. Yeah.
So there's no overlap in terms of their causal chains, or very limited overlap.
Yeah. So I think the only way I can get away with that is to say, right, life could emerge on a planet underneath, and okay,
the lizard people under the crust of the earth.
I think let's go. I think but look, as you can see, we disagree. So,
Yeah.
and I think Sarah actually has convinced me because of that life is a planetary phenomenon. The emergence of life is a planetary phenomena, and actually, because of the way evolution and selection works, then nothing occurs in isolation. The causal chains interact, so there is there's a consensus model for life on the Earth.
But you don't think you can place aliens from elsewhere onto can't you just place multiple alien civilizations on one planet?
Right, but I think so. You can take two original life events that were independent and commingle them, but I don't think when you're talking about when you look at the interaction of that structure, it's like the same idea as like an experiment being an example of life, right? That's a really abstract and subtle concept. And I guess what I'm saying is life is information propagating through matter. So once you start having things interacting, they, in some sense, commingle and they become part of the same chain.
This is
So
why Sarah's
The
a brilliant-
commingling starts quickly.
Yeah.
We proceed to commingle quickly, no
right,
matter
right. So you could say, so the question is then, the more interesting question is, are there two distinct origins events? And I still think that there's reasons that on a single planet you would have one origins event because of the timescales of cycling of geochemistry on a planet, and also the fact that I don't think that the origin of life happens in a pool and like radiates outward through evolutionary processes. I think it's a multi-scale phenomena. It happens at the level of individual molecules interacting, collections of molecules interacting, and entire planetary scale cycles. So life as we know it has always been multi-scale, and there's brilliant examples of individual mutations at the genome level changing global climate, right? So there's a tight coupling between things that happen at the largest scale of our planetary scale and the smallest scale that life mediates.
But it still might be difficult within something you would call as a single alien civilization. There's species and stuff.
But I think
And they might not be able to communicate.
But you're asking about life, not species, right? So
But what's the difference between one living civilization? This is almost like a category question.
yeah.
Versus species, because it can be
Right.
very different. Like
Right,
the way
so-
evolution, because there's like literally islands that you can evolve different kinds of turtles and stuff,
Yeah.
and they can
So I guess what I'm saying is,
weird.
if
in
you look at
different
the
ways.
structure of two interacting living things, populations, and you look in their past and they have independent origins for their causal chain, then you would say one was alien, they have different independent origins events. But if you look at their future, by virtue of the fact they're interacting, their causal chains have become commingled, so that then in the future they are not independent.
Right.
Right. So that's why you would even define them as alien. So the structure across time is two examples of life become one example of life, because life is the entire structure across time.
Right. But there could be a lot of variation within.
Yeah. So the question we're all interested in is how many independent origins of a complexifying causal chain are there in the universe?
See, but is the idea of origin is easy for you to define? Because when the species split in the evolutionary process, and you get like a dolphin versus a human, or Neanderthal versus Homo sapien, isn't there?
Let me make a distinction here, quickly. So I think, sorry to interrupt. What we're saying, I mean, Sarah, won that argument because I think she's right that once the causal chains interact and going forward. So we're talking about a number of things. Let's go all the way back before origin of life. Origin of life
On Earth.
Chemistry emerges. There's all these. I would say there's probably mechanistically the chemistry is desperately trying to find any way to get replicators. The ribosome kind of was really rubbish at the beginning, and they just competed, and you got better and better ribosome. Suddenly, that was a technology. The ribosome is the technology that allowed evolution to start. So why I interrupted you is say that once evolution has started using that technology, then you can speciate. And I was and I think what Sarah said was convinced me of, because I was like, no, we can have lots of different chemistry, shadow biosphere on Earth. And she's like, no. You have to have this, you have to get to this minimum evolutionary machine. And then when that occurs, speciation occurs. So exactly what you say, dolphins, humans, everything on Earth. But when you're looking at aliens or alien life, there's not going to be two different types of chemistry because they compete and interact and cooperate because the causal chains overlap. One might kill the other, one might combine with the other, and then you go on, and then you have this kind of this average. And sure, there might be respeciation. It might be you have two types of emerging chemistry. It almost looks like the origin of life on Earth required two different pre-life forms, the peptide world and the RNA world. Somehow they got together, and by combining, you got the ribosome, and that was the minimum competent entity for evolution. And off we go.
And would all alien civilizations have an evolutionary process on a planet?
Mhm.
So like that's one of the it's almost the definition of life. To
Yeah.
create all those memories, you have to have
Things
something
have to
like,
change in time.
Yeah.
but there has to be selection.
hmm
That's like an efficient. There's no other way to do it.
No. Well, never say never, because as soon as I say that, someone
That's
says,
the part that depresses me, though. Going back to like, I don't know, the earlier discussion on violence and things like, and I don't know where somebody was tweeting about this recently, but like, how much stuff had to die.
Yeah.
Maybe it was you.
Yeah.
Yeah. So yeah, sorry.
So
Like,
we're
all mush in
we're
my
talking
brain.
about life.
Yeah.
And I guess a lot of murder had to occur.
Right. So selection
Death,
means things had to be weeded out, right? So
Well, we can celebrate that. Death makes way to
yeah, I mean, and also, one of the most interesting features of major extinction events in the history of our planet is how much novelty emerged immediately after, right? So, and of course, a lot of people make arguments we wouldn't be here if the dinosaurs didn't go extinct. So, in some ways, we can attribute our existence to all of that. But I guess I was just wondering, and sort of like, if I was going to build a universe myself, in the most optimistic way, would I retain that feature? But it does seem to be a
I think you
universe.
have to. I mean, I think we're probably being over anthropomorphizing. I remember watching the Blue. I think it was the Blue Planet. David Attenborough was showing these seals, and because of climate change, some seals were falling off a cliff, and how tragic that was. And I was saying to my son, that's pretty cool. Like, look at those ones down there. They've obviously got some kind of mutations, and they're not doing that daft thing. Yeah. And so that poor gene will be weeded out. Of course, at the individual level, it looks tragic. And of course, as human beings, we have the ability to abstract and we empathize. We don't want to cause suffering on other human beings, and we should retain that. But we shouldn't look back in time and say, how many butterflies had to die? I remember how many. If you think about the caterpillar becoming the chrysalis and then the butterfly getting out, how many, if that suffering, we call it suffering, if that process of pruning had not occurred, we have no butterflies. Mm-hmm. So none of the butterfly beauty in the world without all that pruning. So pruning is required, but we shouldn't anthropomorphize and feel sorry for the biological entities. Because that seems to be a backwards way of looking at it. What we should do is project forward and maybe think about what values we have across our species and our ecosystem and our fellow human beings. Yeah. Now that we know that animals suffer at some level, think about humane farming. When we find that plants can, in fact, are conscious and can think and have pain, then we'll do humane gardening. Until that point, we won't do it, right?
I like this. Famous chemist endorses the majestic nature of murder. That's the title.
Well, I didn't say that, but okay.
Well, I just inserted.
I have a hard time with it, though. I think the way you put it is kind of.
But it's the reality of it is beautiful. There's an Instagram account called Nature is Metal, and I keep following and unfollowing it because I can't handle it for prolonged periods of time.
We evolve together, you die alone.
Yeah.
We evolve together, but you die alone.
So
you live alone too. It's the Gatsby thing. I don't know. We evolve together. Where's the together? The together is the murder.
The population
and the sex.
I just try
sex
to
and murder.
My romantic vision of it, to try to make me happy Sarah instead of sad Sarah. I talk in third person when I think very abstractly. Sorry. Is like this whole the certain things can coexist. So the universe is trying to maximize existence, but there's some things that just aren't the most productive trajectory together, but it doesn't mean that they don't exist on another timeline or another chain somewhere else. And maybe you would call that then some kind of multiverse or things, but what am I saying?
I think you can't. You can't go down a
I'm
level.
just making stuff up to
No,
make
you're
myself
not. No,
feel
no.
better.
I don't understand. It is illogical, and we need.
I know.
Yeah, if you look at bacteria, if you look at virus, I mean, just the number of organisms that are constantly like looking at bacteria, they're just dying nonstop. It's like a slaughter.
Right.
So,
well, and this goes back to the conversation about God. I mean, like, there's the whole thing about like, why does the universe enable suffering?
individuals don't exist, right? So for this, I think if you think about life as an entity on Earth, right? Let's just go back a second. I mean, I'll be ludicrous for a second. I don't exist. You don't exist, right? But the actions you do, the product of evolution exists, right? The objects you create exist quantitatively in the real world. If you then understand life on Earth or alien life or any life in the universe as this integrated entity where you need cells in your body to die, otherwise you'd just get really big and you wouldn't be able to walk around, right? So you do.
Yeah.
So I think
it's the patterns that persist, not the physical things.
And of course, we place immense values on fellow human beings, and I'm majestic professor does like other individual human beings. Or
now you're talking in third person too.
I know it happens, right?
So death, would you say? I mean, because you said evolution is a fundamental part of life. So death is a fundamental part of life.
Yeah. It might right now. It might not be in the future. We might hack some aspects of death. And we'll evolve in different ways.
But isn't there? I think Sara mentioned like this life density. Can't that become a problem? Like too much bureaucracy, too much baggage builds up. Like you need to keep
I think it's okay
stuff.
That we dissipate. I don't think of it like I mean,
dissipate. Yes.
No, but I mean like we're so fixated on ourselves as individuals and agents, and we were talking about this last night actually over dinner. But like an individual persists for a certain amount of time. But what you want to do, like if you're really concerned with immortality, is not to live indefinitely as an individual, but maximize your causal impact. So like, what are the traces of you that are left? And you're still a real, I always think of Einstein, like for a period of time, he was a real physical thing we would identify as a human. And now we just see echoes of that human in all of the ways that we talk about his causal impact. Or Frank Lloyd Wright is another great example.
How many Easter eggs could you leave in the future? It's like, I got you.
So I guess the question is, how much do you want to control the localization of certain features of, say, a packet of propagating information, we might call a person, and keep them localized to one individual physical structure? Or do you want to, is there a time when that just becomes a dissipated feature of the society that it once existed in? And I'm okay with the dissipated feature because I just think that makes more room for more creativity in the future.
So you mentioned engineering life in the lab. Let me take you to computer science world. What about robots? So is it possible to engineer? See, because you're really talking about like engineering life at the chemistry level. But do you think it's possible to engineer life at the like humanoid level, at the dog level? Like, or is that like at which level can we instill the magic of life into inanimate stuff?
No, I think you can do it at every level. I just think that we're particularly interested in chemistry because it's the origin life transition that presumably, or at least that's how I feel about it, is going to give you the most interesting or deepest insights into the physics. But presumably everything that we do and build is an example of life. And the question is just how much do you want to take from things that we have now and put them into like examples of life and copy them into machines? I don't know.
I saw that there was this tweet again. I think you were at the Mars conference and you were hanging out with a humanoid robot.
Yes. That was a fun
Making
conference.
Lots of new friends at Mars 2020. Did you guys color match ahead of time with the robot, or did that accidentally happen?
Accidentally, I went up and I wanted to say hi.
Turquoise, would that be the correct name for the color?
Yeah.
I think so. We didn't color coordinate our outfits.
Well, you didn't. Maybe the robot did.
The robot probably did. Much more stylish.
So for people who are just listening, there's a picture of Sara standing next to a humanoid robot. I guess you like them with a small head and perfect vision.
Actually, no. I just
I did there. Perfect. There's a LiDAR.
No, I mean, I think I was just deeply interested because,
What was, sorry to interrupt, but was it manually controlled? Was it actually stabilizing itself?
oh no, it was walking around.
Oh, nice.
Yeah,
Nice.
it was pretty impressive. I mean, actually, there's some videos online of Jeff Bezos walking with one of those across the lawn nearby there.
This is
So,
great.
yeah. So,
I wasn't invited.
um, yeah, but there you go. See?
That's incredible, isn't it?
Yeah.
So you look at the walking robot. Where did the idea for walking come from? It was invented by evolution, right? And us as human beings able to conceptualize and design and engineer. So the causal chain. So that robot is evidence of life. And so I think what's going to happen is there's the we want to find where the spark comes from mechanistically. How can you literally go from sand to cells? So that's the first transition that I think, there are a number of problems we want to do. Make life in the lab. Great. Then we want to make life in the lab and want to suddenly start to make intelligent life, or life that can start to solve abstract problems. And then we want to make life that is conscious. Okay?
In that order?
I think it has to happen in that order. This getting towards this artificial general intelligence. I think that artificial general intelligence can't exist in a vacuum. It has to have a causal chain all the way back to Luca, right?
Yeah.
And so the question, I think, I really like the question, is to say, what are we? How is our pursuit of more and more lifelike? I know you like your robots, you want to project into them, you want to interact with them. I think you would want, if you have a robot dog and the robot dog does everything expected of a normal dog and you can't tell the difference, you're not really going to ask the question anymore if it's a real dog or not, or it's got a personality, you're interacting with it. And so I think what would be interesting would be to kind of understand the computational architecture, how that evolves, because you could then, teleport the personality from one object to the other and say, right, does it act the same? And I think that as we go along, we're going to get better and better at integrating our consciousness into machines.
Well, let me ask you that question just so to linger on it. I would call that a living conscious thing potentially.
Mm-hmm.
I as a human allegedly, but would you as a person trying to define life, if you pass the Turing test, are you a life form?
One of the reasons I walked up to the robot was because I wanted to meet the robot.
Right.
Right. So it felt like I was, and I base a lot of my interaction with reality on emotion and feeling, but like how do you feel about an interaction? And I always love your point about, like, is it enough to have that shared experience with a robot, right?
Mm-hmm.
So walking up to it, does it feel like you're interacting with a living thing? And it did, to an extent, but in some degrees it feels like you're interacting with a baby living thing. So I think our relationship with technology, in particular the robots we build, is really interesting because basically they exist as objects in our future in some sense. Like, we're a much older evolutionary lineage than robots are, but we're all part of the same causal chain. And presumably, they're kind of in their infancy. So it's almost like you're looking at the future of life when you're looking at them, but it hasn't really become life in a full manifestation of whatever it is that they're going to become. And the more the example of the walking robot was super interesting, but they also had a dolphin that they put in the pool at the cocktail party at Mars, and it looked just like a real dolphin swimming in the pool. And it's in this kind of uncanny valley because, and I was having this conversation with a gentleman named Mutu who was super perceptive, but he was basically saying, like, it made him feel really uncomfortable. And I think
the dolphin.
Yeah, and I think a lot of people would have that response. And I guess my point about it is kind of interesting because you're basically trying to make a thing that you think is non-living mimic a living thing. And so the thought experiment I would want to run in that case is, imagine we replaced every living thing on Earth with a robot equivalent, like all the dolphins and things. And in some sense, then you're making, if you think that the robots aren't experiencing reality, for example, in the way that a biologically evolved thing would, you're basically making the philosophical zombie argument become real.
Yeah.
And basically building reality into a simulation because you've made everything quote unquote fake in some sense. You've replaced everything with a physical simulation of it.
So as opposed to being excited by the possibility of creating something new, you're terrified of humans being replaced.
I was just trying to run like what would be the absolute, thought experiment, but I don't think that scenario would actually play out. I guess what I think is weird for why we feel this kind of uncanny valley interacting with something like the robot dolphin is we're looking at an object we know is kind of in the future in the sense of like if everything's ordered in time, but it's borrowing from a structure that we have common history with, and it's basically copying in a kind of superficial way things from one part of the causal chain to another. Yeah.
Well, that's a video
Everyone
of
believed it was real. They look so real. And obviously the technology was developed for movies, so
But I think we're confusing our emotional response and understanding the causal chain of how we got there, right? Because the philosophical zombie argument thinks about objects just appearing, right? That you're facsimiled in some way, whereas the chain of events that caused the dolphin to be built went for a human being.
Yeah, would philosophical zombies still have a high assembly index?
Yeah. Because it can't be philosophical zombies can't like Boltzmann brains just can't appear out of nowhere.
well, I guess my question would be in that scenario where you built all the robots and replaced everything on Earth with robots, would the biosphere be as creative under that scenario or not?
Yeah. No,
And so are there quantitative differences you would notice over time?
And it's not obvious either way, right?
It's not obvious right now because we don't understand. We haven't built into machines how we work.
So that's, I think, there are one of the big missing things that I think that we're both looking for,
This is
right?
a robot. It's a cute robot.
But the point, Sarah, is that the biosphere won't be as creative if you did it right now.
No, of course. I think that's why people don't like it.
But in the future, we will be able to solve the problem of origin of life, intelligence, and consciousness. Because they exist in physical substrates. We just don't understand enough about the material substrate and the causal chain. But I'm very confident we will get to an AGI, but it won't be what people think. It won't be, solution won't be we'll get fooled a lot. And so GPT-3 is getting better at fooling us, and GPT 153 might really fool us, but it won't have the magic we're looking for. It won't be a creative, but it will help us understand the differences between
really though, because isn't that what love is? Being fooled. Like what? Why are you not giving much value to the emotional connection with objects, with robots, with humans?
Emotion is that thing which happens when your your expectation function is dashed and something else happens, right? I mean, that's what emotion is.
Is that what love is too?
Yeah.
You were expecting one thing and something else happened.
Yeah.
I don't know.
I don't think that's true either.
Well, what is it then? I think no emotion. Look, I'm sorry, emotion is that, but that's
No,
not
I think love is just fulfilling your purpose.
no. But okay, I mean, look.
Like whatever that means. That's.
I mean, really. So yeah, okay. So,
but when are you happiest? Is like when you're.
All right,
doing,
all right, right. Let me go back. If you want me to
follow
define,
your bliss.
let me define love quickly.
Okay, go for it.
In terms of assembly spaces, right? Okay.
Excellent.
I didn't think I'll be doing this today.
I can't wait till Assembly Theory 101 is taught, and the second lecture is Assembly Theory of Love.
No, but look, well, but actually, but
It's being surprised. The expectations being broken.
I'm not.
No, go for it. I want to hear you.
I'm not an emotional being, but I would say so. Let's talk. So we'll talk about emotion a bit, but love is more complex. Love is a very complex set of emotions together and logical stuff. But if you've got this person that's on this causal chain that has this empathy for this other thing, love is being able to project ahead in your assembly space and work out what the person you're in love with has a need for, and to do that for them without selflessly, right? Because you can project ahead what they're going to need, and they are there, and maybe you can see someone is going to fall over, and you catch them before they fall over, or maybe you can anticipate that someone's going to be hungry, and without helping you just help them. That's what
that just sounds like empathy.
But it's more complex than that, right? It's more complex. It's more about not just empathy, it's understanding. It's about kind of sharing that experience.
That's an expression of love, though. That's not what it's like to feel love.
Right, exactly.
Like feeling love is like, I think it's like when you're aligned with things that you feel like are your purpose or your reason for existing.
So if you have those feelings towards a robot, why is that robot? I mean, because you said like the AGI will build an AGI, but it won't. There'll be a fundamental difference in AGI
I don't think
and
we'll
human.
build it. It's going to merge from our
But
technology.
I think you guys all arguing the same thing.
Yeah.
I just said that that we do not correctly capture the causal chain that we have
within
into our-
GPT.
within
But
AI.
don't you think it captures, because GPT-3 is fundamentally trained on a corpus of knowledge, like the internet? Don't you think it gets better and better and better at capturing the memory of all of the?
It will be better at fooling you, and at some point you won't care. But when it comes, my guess, this is as all I was getting to right before we got. I got in the love trap.
Love trap. Yeah,
it was like Lee Cronin in the love trap.
Yeah. Sounds like a good band name.
Makes it sad. Okay, sad. Assembly space of sad. No, is that so? Sure, but I think there are other features that that we pull on innovation that allow us to do more than what we just see in GPT-3. So if you're being fooled there. So I think what I mean is human beings have this ability to be surprising and creative, whereas, is it DALL-E, this thing, or if you take GPT-3 is not going to create a new verb. Shakespeare created new verbs. You're like, wow. And that required Shakespeare to think outside of language in a different domain. So I think having that connections across multiple domains is what you need for AGI.
Yeah, but I don't know if you need. I don't know if there's any limitations GPT-N not being able to be cross-domain.
The number one problem is it's instantiated in a resource-limited substrate that we don't in silicon. The architectures used for training for learning is about fooling. It's not about understanding. And I think that there is some understanding that we have that is not yet symbolically representable.
Learning language and using language seems to be fundamentally about fooling, not understanding. Why do you use language exactly?
I might disagree with that quite fundamentally, actually. But I'm not sure I understand how to make a coherent argument for that. But my feeling is that there is comprehension in reality in our consciousness below language. And we use those for language, for all sorts of expressions, and we don't yet understand that. There's a gap. We will get there. But I'm saying, wouldn't it be interesting? It's a bit like saying, could I facsimile you or Sara into a new human being, right? And let's just say I could copy all your atoms and the positions of all your atoms, the electrons, into this other person. They would be you. The answer is no. And it's quite easy to show using assembly theory, because actually the feature space that you have, that graph, the only way to copy you is to create you on that graph. So everything that's happened to you in your past, we have to have a faithful record for. If you want another copy of Lex, you have to do the exact thing. Want another copy of Sara, want another copy of Lee, the exact past has to be replicated.
Let me push back on that a little bit. That's maybe from an assembly theory perspective, but I don't think it's that difficult to recreate a version of me, like a clone, that would make everybody exactly equally as happy. Like they wouldn't care which one. And like there's two of me, and then they get to pick which one, and they'll kill either one. They'll be fine as long as they're forced to kill.
They'll be fine. But here's what will happen: is let's say we make artificial Lex, and everyone's like, "Wow, it's so cool! It looks the same, interact."
Yeah.
Then there'll be this battle of like, right, we're going to tell the difference. We're going to basically keep nudging Lex and artificial Lex until we get in novelty from one, and we'll kill the other one. And I think, thank God,
we're not. Novelty is a fuzzy concept. That's the whole problem of novelty.
So I will define novelty. It's not fuzzy. Novelty is the ability for you to create architectures that are or create an architecture. So let's say you've got a corpus of architectures known. You can write down, you've got some distance measure.
Yeah.
And then I create a new one, and the distance measure is so far away from what you'd expected. There's no linear algebra going to get there. It's like, that is creativity. And we don't know how to do that yet on any level.
Well, I was also thinking about like your argument about free will, like you wouldn't be able to know it doesn't work instantaneously. It's not like a micro level thing, but more a macro level thing over the scale of trajectories or longer term decisions. So if you think that the novelty manifests over those longer time scales, it might be the two Lexes diverge quite a bit over certain timescales of their behavior,
But
even
nobody
though
would notice the difference.
they might not.
And the Earth won't notice the difference. The universe won't notice
The
the
universe
difference.
would notice the difference.
No, the universe doesn't know about its novelty that's being generated. That's the whole point of
What,
Yeah, but this is
novelty.
what selection is, right? It's like
Yeah.
taking nearly equivalent ones and then deciding, like the universe selects, right? So whatever selection is, selects some things to persist in time.
Yeah, it's
So
going to select the artificial one
So
just
what
because
I'm
it
trying,
likes that one better.
well, you're mixing up two arguments here. So look, let's go back a second.
And
what are you basing this argument on, Lex?
I'm just saying that I kind of don't think, because Lee said that it's not possible. Like if you if you copy every single molecule in a person's body, that's not going to be the same person. That they won't have the same assembly index. It won't be the same person. And I just don't. I think copying, you can compress. Not only do I disagree with that, I think you can even compress a person down to some where you can fool the universe.
I'm saying, let me restate it. It is not possible to copy somebody unless you copy the causal history.
Also, you can't have two identical. I mean, actually, I really
Sure.
like the idea that everything in the universe is unique. So even if like there were two Lexes,
I know you like that idea because you're human and you think you're unique.
Yeah, exactly. But also, I can make a logical argument for it that even if we could copy, all of your molecules and all their positions, the other you would be there, and you have a different position in space.
And the other
You're
thing,
distinguishable.
yeah, the other thing I was
But
going to add.
how unique are you? Just by the position in space, really?
Sure, but then
But
how
how
much does
interesting
that
is that?
slight translation of Lex
Well, that's
sitting
what I'm gonna-
there
That's not an
affect
interesting.
the future?
I see, but no. Wait a minute. Is part of the definition of something being interesting is how much it affects the future?
Yes.
Yes. But let me come back.
Don't you agree?
But let me come
Do you
back
disagree?
to one point quickly that you were making.
Sure, I think I probably agree. Yes.
If there's two Lexes, right? There's a robot Lex that you just basically it is a charade. It's a facsimile. It's just coded to emulate you.
Are you robot Lex?
But
I wouldn't know.
Let's
right?
get there. But let's
That's
get there.
the
It's a very
point. I
very
wouldn't know.
important point here because he's ducking and diving between this eye. So if I facsimiled you into a robot, then your robot would be a representation of you now, but fundamentally be boring because you go and have other ideas. If, however, you built an architecture that itself is capable of generating novelty, you would diverge in your causal chain, and you'd both be equally interesting to interact with.
Yeah.
We don't know that mechanism. All I'm trying to say is we don't yet know that mechanism. We do not know the mechanism that generates novelty, and at the moment, in our AIs, we are emulating. We are not generating.
You don't think we're sneaking up on that?
No.
Do you think it's a
No,
fundamental?
there is no ghost in the machine. And I want there to be one. I want the same thing you want. Sorry, I was
I know you
interrupting.
want that as a human because everything you just said makes you feel more special.
I want to be...
than
No.
GPT-3.
Screw my specialness. I just want to be surprised. If I
You don't think a robot can surprise you?
if you can produce an algorithm instantiated in a robot to surprise me, I will have one of those robots. It'll be brilliant. But it won't surprise me.
But why is it a problem to think that humans are special?
Maybe it's not the special. You're right. It's the better than.
Yes.
Because then you start to not recognize the magic in other life forms that you
Right.
either have created or you have observed. Because I just think there's magic in legged robots moving about, and they are full of surprises.
Yeah.
So this,
And personality.
yeah. So I'm a little.
I know why you like cellular automata, right? But the specialness in your robot comes from the roboticist that built it.
Yeah.
It's
Yeah.
part of the lineage. It's-
Yeah.
And so that's fine. I'm happy with that.
That's what I felt like looking at the standing robot was I was looking at 4 billion years of evolution.
Yeah.
Right.
If it wasn't,
Yeah.
so I think
Yeah.
I'm happy. I mean, I'm happy we're going to coexist. I'm just saying you're going to get more excitement. There's something missing in our understanding of intelligence. Intelligence isn't just training. The way the neural network is conceived right now is great and it's lovely and it'll be better and we'll argue forever. But you want to know, wouldn't it be great if I said, look, I know how to invent an architecture and I can give it a soul. Now, what I mean by a soul is I know for real that there is internal reference. As soon as not fake internal reference, and if we could generate that mechanism for internal reference, that's why our goal directness.
That's why you have to
we can do
develop
that.
the test for goal directedness. Yeah.
Get that goal directedness. You would love that robot more than the one that's just made to look like it does, because you'll have more fun with it, because you'll be able to generate, search other problems, get more novelty. Hell, you'll be able to fall in love with that robot for real, but not the one that's faking it.
What about fake it till you make it?
Well, I think a lot of people fall in love with fake humans.
Yeah.
It's nice to fall in love with something that's full of novelty. Yes, I could imagine all kinds of robots that I would want to have a close relationship with, and I don't mean like sexual. I mean like intimacy. But I just don't think that novelty generation is such a special. Okay, there's like mathematical novelty or something like that, and then there's just humans being surprised, and I think we're easily surprised.
That's fine, but that's that.
But you don't think that's a good definition?
No, that's
of
good.
novelty?
I'm happy to be surprised, but not globally surprised because someone else. But I really want. Why I'm a scientist. I really want to be the first to be surprised about something, and the first thing in the universe to have created that novelty, and to know for sure that novelty has never occurred anywhere else. That's a real buzz, right?
Is there a way to really know that?
You have to have a really big lookup table.
Right.
Yeah, you're never going to know for sure, right? That's one of the hard things about being and scientists searching for this type of novelty. Maybe that's why mathematicians love discovery, but actually they are creating, and then when they create a new mathematical structure that they can then you can write code to work out whether that structure exists before. That's almost why I would love to have been a mathematician from that regard, to invent new math that really I know pretty much for sure does not exist anywhere else in the universe because it's so contingent.
Right, but this gets into like you said a few times that I still really don't understand how you actually plan to do this, to build an experiment that detects how the universe is generating novelty or that time is the mechanism. So the problem that we all have, which I think is what Lex is pushing against, is if I build the experiment, you don't know what you put into it. So you don't know what, like if you, unless you can quantify everything you put in, all of your agency, all the boundary conditions, you don't know if you somehow biased it in some way. So is the novelty actually intrinsic to that experiment or to that robot, or is it something you gave it but you didn't realize you gave it?
It's going to asymptote towards that, right? You're never going to know for sure, but you can start to take out, you can use good Bayesian approaches and just keep updating and updating and updating until you point to all intents and purposes.
So you want to bound on how much novelty generation could be.
Yeah.
Got it.
So the ability to generate novelty is correlated with high assembly index?
Yeah.
With assembly index?
Yeah. And yeah.
Because the space of possibilities is bigger.
So that's the key. This could be a good so we're running joke of like why Lex is single. This could be a good part 4. So what you're looking for in a robot partner is ability to generate novelty. And that's, I suppose you would say, it's a good definition of intelligence too.
Mm-hmm.
Boy, is novelty a fuzzy concept.
Is creativity better?
Yeah, I mean that's all pretty fuzzy.
It's kind of the same. Yeah. Maybe that's why aliens haven't come yet. Is because we're not creating enough novelty. Like there's some kind of a hierarchy of novelty in the universe.
Well, I think novelty is like things surprise you, right? So it's a very passive thing. But I guess what I meant by saying creativity is I think it's much more active. Like you think there's like a mechanism of like the things that exist are generating the creativity. Novelty seems to be there's some spontaneous production. It's completely decoupled from the things that exist.
No, I understand. Right. I think
that's really, really good.
Creativity is the mechanism and novelty is the observable.
Yeah.
Novelty could just be surprise. Your model of the world was broken and not necessarily in a positive way.
So that's surprise. So there's 3 things now. Let's go back. That's cool. Right, let's go. Okay. You got surprise, which is basically I'm surprised all the time because I don't read very much. I'm pretty dumb. I was like, oh wow, I often used to invent new scientific, ideas, and I was really surprised by that. And then when looking at literature properly, and it's there. So surprise, that's to the extent that you don't have full information. Creativity, the act of pushing on that kind of on the causal
Mhm.
structure, and novelty, which is measuring that degree,
Mhm.
right? So, and I think that's pretty well defined in that regard. So you want your robot. I mean, in the end, that's why actually the way the internet and the printing press share some. I actually think creativity has dropped a bit since the internet, because everyone's just regurgitating stuff. But of course, now it's beginning to accelerate again because everyone's using this tool to be creative, and boom, it's exploding. So I think that's what happens when you create these new technologies. Isn't it?
That's really helpful. There's a difference between novelty and surprise. Okay. I think I was thinking about surprise.
If you give me a toy that surprises me for a bit, it'd be great. A robot that surprises me,
An experiment that surprises you.
Yeah, I mean, that's why I love doing experiments, because I can't.
It's still exciting.
Yeah.
Surprise is exciting.
Yeah.
Even negative surprise. Like, some people love drama in relationships. Like, it's like, why the hell? Why'd you do this? That could be exciting too.
I could imagine companies selling updates to their companion robots that just basically generate negative surprise, just to spice things up a bit.
Yeah, it's the push and pull. That's one of the components of love. As you said, love is a complicated thing. Oh, beauty. I wanted to mention this because you also tweeted, I think this was Sara. No, it might have been Lee. I don't remember. But it was a survey published in Nature showing that scientists
That was
find.
me,
Yeah. Anyway, there's a plot. This is published in Nature of what scientists find beautiful in their work, and it separates biologists and physicists. It'd be nice if you showed the full plot.
Mhm.
And there's simplicity, elegance, hidden order, inner logic of systems, symmetry, complexity, harmony, and so on. Is there any interesting things that stand out to you?
I think the fact that biologists like complexity and pleasing colors.
Oh, there's pleasing colors on there? Yeah.
Or shapes.
Or shapes. Pleasing
Yeah.
colors or shape. And then physicists obviously love simplicity above
Simplicity
all
and
else.
elegance.
Simplicity, elegance.
Yeah.
They love symmetry. And then biologists love complexity. And, they just love a little bit less.
They love everything a little bit less, but complexity a little bit more.
A little bit more. That's so interesting.
And pleasing colors or shapes.
Do you think it's a useful? I forget what your tweet was, that this is missing some of the. Something.
No, I think it's because I think about how explanations become causal to our future. So I have this whole philosophy that the theories we build and the way we describe reality should have the largest breadth of possibilities for the future of what we can accomplish. So in some sense, it's not like Occam's razor is not for simplicity, it's for optimism or the kind of future you can build. And so I think you have to think this way when you're thinking about life and alien life, because ultimately we're trying to build. I mean, science is just basically our narratives about reality. And now you're building a narrative that is what we are as physical systems. It seems to me it needs to be as positive as possible, because it's basically going to shape the future trajectory where we're going. And we don't use that as a heuristic in theory building, because we think theories are about predicting features of the world, not causing them. But if you look at the history of all of the development of human thought, it's caused the things that happen next. So it's not just about looking at the world and observing it. It's about actually that feedback loop that's missing, and it's not in any of those categories.
What do you think is the most beautiful idea in the physics of life, in the chemistry of life, in this, through all your exploration with assembly theory? What is the thing that made you step back and say this idea is beautiful, or potentially beautiful?
For me, it's that the universe is a creative place. I guess I want to think, and whether it's true or not, is that we are special in some way, and it's not like an arbitrary added on epiphenomena or ad hoc feature of the universe that we exist, but it's something deep and intrinsic to the structure of reality. And to me, the most beautiful ideas that come out of that is that the reason we exist is for the universe to generate more things and to think about itself and use that as a mechanism for creating more stuff. That's for me.
Like the life that this, however common it is an intrinsic part, is a fundamental part of this universe, at least, that we live in?
I think so. I mean, it's always interesting to me because, like we have theories of quantum mechanics and gravity, and they're supposed to be like our most fundamental theories right now. And they describe, things like the interaction of massive bodies or the way that charges accelerate or all these kind of features. And they're these really deep theories, and they tell us a lot about how reality works, but they're completely agnostic to our existence. And I can't help but think that like whatever describes us has to be even deeper than that.
And I think incorporating memory, I guess, or
Yeah.
causality, whatever the term you want to use, into the physics view of the world might be taking
That's
a
the
step in
easiest
that
way to
direction.
do it. It's the cleanest. So here we go again with the physicist. I'm a physicist. I was going to say the simplest, most elegant way of resolving all of the kind of ways that
What?
we have these paradoxes associated with life. It's not that life is not current physics is not incompatible with life, but it doesn't explain life. And then you want to know where are the explanatory gaps. And this idea that we have an assembly that time is fundamental and objects actually are extended in time and have physical extent in time is the cleanest way of resolving a lot of the explanatory gaps.
So I struggled with assembly theory for many years because I could see this gap. And I think when I first met Sara and we realized we were kind of talking about the same problem, but we understood none of the language. It was quite hilarious actually, because it's like, look, I have no idea what you're talking about, but I think it sounds right. So for me, the most beautiful thing about assembly theory is I realized the assembly theory explains why life is a universe developing a memory. But not only that, poetically, I could actually go and measure it. And I was like, holy shit! We physically measured this thing, this abstract thing, and we could measure it. And not only could we measure it, but we can then start to quantify the causal consequences. Because, I mean, I think as a kind of inventing this together with Sara and her team, I thought there was quite a high chance that, we're doing science. There's such a high probability we're wrong.
Mm-hmm.
On
Every day.
on this. And I remember kind of trying to go to hard physicists, mathematicians, complexity theorists, and everyone just kind of giving me such a hard time about it. And said, you've just done this, you've just done that. You've just recapitulated an old theory. And I was unable, I lacked the language to really explain. And it was a real struggle. So this realization that what life does, that physics cannot understand, or chemistry, is the universe develops a memory that's causally actionable. And then we can measure it, but it isn't just one thing. There is this intrinsic property of all the objects in the universe, like I've said before. But me holding up this water bottle is just any other water bottle, but it is a sum total of all the water bottles that have existed, right? And will likely change the future of water bottles and for other objects. So it's this kind of. So for me, assembly theory explains the soul in stuff.
Mm-hmm.
The monadology.
But it is the monadology. It's not like Sheldrake's morphic resonance, where we have this kind of wooey thing permeating the universe. It is the interaction of objects with other objects. And some objects have more instantaneous causal power. That's life, living things. And some objects are the instantaneous output of that causal power, dead objects, but they're part of the lineage. And that for me is fascinating and really beautiful. And I think that even if we're determined to be totally wrong, I think it will help us hopefully understand what life is and go into tech life elsewhere and make life in the lab.
How does that make you feel, by the way? Does it make you feel less special that you're so deeply interconnected to the lineage?
I mean, on one level, I just wanted in my life as a scientist, I wanted to have an interesting idea just once, or an original idea. I mean, it was like, so I think that was cool that we had this idea and we were playing with it. And I think also that it took me ages to realize that Sara had also had the same kind of coming towards the same formulation, just from a completely different point. Because but no, it makes me feel special, and it also makes me feel connected to the universe. It also makes me feel not just humble about being a living object in the universe, but the fact that it makes me really optimistic about what the universe is going to do in the future, because we're not just isolated phenomena, we are connected. I will be able to have, one of my small objectives in life is to change the future of the universe in some profound way just by existing.
Yeah, that's not ambitious at all. Uh,
I think it's also good because it makes me feel less lonely, because I just realize I'm not I'm a unique assembly structure, but I have so much overlap with the other entities I interact with that we're not completely individual, right?
And yet your existence does have a huge amount of impact on how this whole thing unrolls on the future of the
As
world.
individuals, that's,
But I was going to say,
local packets of agency.
I think we all have a profound impact on the future, some more than
Yeah.
others, right? All human beings, all life. And I mean, that's why I think it's a privilege in a way for, to say, to assert some degree of ego and agency. I'm going to make a computer or make an Origin Life machine, or we're going to do this thing. But actually, it's just like, life's probably living. If there is a God or there's a soul in everything, it's probably laughing at us going, I fool these guys by giving them ego. So they strive for this stuff. And look what it does for, the assembly space of the universe.
And there's always a possibility that science can't answer all of it. So that part's challenging for me.
There might be a limit to this thing. Let me ask you a bunch of ridiculous questions, and I demand relatively short answers. Lee, what's the scariest thing you've ever done? Yeah, or what's a scary thing that pops to mind?
Giving seminars in front of other scientists.
That is terrifying. I could, if I had
scariest, really?
more time, I would ask you about the most embarrassing, but we'll spare you. What about you, Sarah? Scariest thing? Up there, some of the scary things you've done.
Actually, the scariest for me was deciding I wanted to get divorced, because it was like a totally radical,
life transformation.
Yeah, because we had been married for a really long time. And I think it was just so much I realized so much of my individual agency I didn't realize I had before. And that was just really scary, empowering, scary, but terrifying. You were living in a kind of one way for your whole life, and then you realized your life could be a different way. And
yeah, there's a between humans. I mean, that's the beautiful thing about love is the connection you have, but it's also becomes a dependency, and breaking that, whether it's a mentor, with your parents,
it's almost like friends. Waking up, just there's a different reality. Yeah, that was scary.
Reinventing yourself. Okay, if you could, Lee, we'll alternate. Sarah, if you could be someone else for a day, someone alive today who you haven't met yet, or maybe you could do one who you've met, who would it be?
Kim Kardashian. No joke. The woman's brilliant. I would just like to experience. I think she's got such an interesting and very deep understanding of social reality.
But you also said you have appreciation, a love for fashion.
I do. Well. But that's actually the same. I just think it's really interesting because we live in a social reality which is completely artificially constructed, and some people are really genius about moving through that. And I think she's particularly good at it.
I wonder if she's good at understanding, or if she's.
I think it's very deeply intrinsic to her. So I don't know if she's
surfing a wave.
How much cognitive awareness she has of it, or how strategic it is. But I think it's deeply fascinating. So I guess that's the first one that comes to mind.
What about you, Lee? If you could be somebody for a day, don't say Yosha Bach.
Don't say Kim Kardashian.
Yeah, right. Those two off the table.
Off the table.
No, I was going to say I'd like to be does it have to be here today? I was going to say I'd like to be the latest ARM processor. I would like to be the latest ARM processor. I would like to understand I would like to know what it would feel like to basically.
You like being objects.
I like being. I've always obsessed with being objects ever since I was a kid.
What's the best part of being an ARM processor for a day?
I mean, I'd like to understand how I access my memory, what I anticipate's coming next in clock cycles.
What about how it feels like?
Yeah, I want to know how it feels like to be
useful.
To be.
I mean,
thanks for that.
All right. If everyone on Earth disappeared and it was just you left, what would your days look like? What would you do? Nobody else left to impress. Probably can't really do any real science at scale. What would you do? with your remaining days
Get
on Earth?
every possible tool I could and put it in my workshop and just make stuff.
So try to make stuff.
Just try and make stuff. Make companions. I'm probably not making companions. Probably just
So in the physical space.
yeah.
What about you, Sarah? What would you, when you're just left alone on Earth, you're the
Are there
last
animals in this scenario? Nothing.
No living beings.
No plants?
No plants.
Oh, interesting. I was going to say I would try to walk the entire planet, at least all the landmass.
Well, that's true. So you probably don't know if there's stuff you could be searching for plants or other humans. Or
What would
other
I eat?
It's
It's a
you
very
just have
unrealistic scenario.
daily
No, but
allotment
I would just walk all the time, I
of
think.
Soylent.
I don't know why I
Just walk.
that's just
You're
what came
the
to mind.
explorer.
I would just walk. And I guess I would make a goal of covering all of the entire Earth. Because what else are you going to do with your time?
What's an item on your bucket list, Sarah, that you haven't done yet but you hope to do? Skydiving. Travel to space.
I don't know. You know what's funny with my bucket list? I only know it was on my bucket list once I check it off.
Once you check it off. So your bucket list is like a fog. It's like a mystery.
Yeah.
And you almost by doing it.
Yeah, so it's very subconsciously driven.
So it's in your subconscious in there. And
I think
you're
so.
bringing it to the surface.
I think most of the steering of our agency is in our subconscious anyway, so I just kind of go with the flow. But I guess, no, seriously.
Yeah, no, I get it. Yeah, it's nice.
I don't know. But I would like to go in a submarine, like to the bottom of the ocean. I think that'd be really cool.
To the bottom of the ocean. Are you captivated by the mystery of the ocean? Like how
I
little we
am.
know?
Yeah.
Yeah. What about you, Lee? What item on your bucket list?
I don't have a bucket list, but I've just made one. I would love to take a computer to the moon or Mars and make drugs off world. Be the first chemist to make drugs off world.
The first drug manufacturer in space.
Yeah, why not? Drugs in
do
space.
they have to be somehow like be able to habitate, like to be able to survive on that particular space? Or like what's the connection between being on Mars and doing manufacturing?
I just would like to be that. I'd like to take the ability to have command and control over chemicals programmatically off Earth to somewhere else in the universe.
That just seems like you like difficult engineering problems.
Before I die, if I can do that,
would you travel to space before you die?
Yeah, that's what I'm saying. I'd love to go into space, but not just to be a tourist. I want to take scientific experiment in space and do a thing in space that's never been done before.
That's a real possibility.
Yeah. So that's why there's no point in listing things I can't do. Yeah.
All right. What small act of kindness were you once shown that you will never forget? Small act of kindness, not big. Somebody was just kind to you. Somebody did something sweet.
When I was a PhD student, someone helped me out with I needed a computer. I needed some power, computation power, and someone took pity on me and helped me and gave me. I was really touched. They didn't have to, and they were actually quite. They were a disabled scientist. They had other things to do rather than help some random PhD student. Gave me access, taught me a lot of stuff.
Yeah, actually, when you're a grad student or when you're a student, when you're even a student, the younger it is, the better. The attention, the support, the love you get from an older person, a teacher, something like that, is super powerful. It's fascinating. And like from the perspective of the teacher, they might not realize the impact they have, but that little bit, those few words, a little bit of help can have a lot of impact. What about you, Sarah? Somebody give you a free Starbucks at some point?
I love free Starbucks. I like it when you're like in the line at Starbucks and somebody buys your coffee in front of you and then you buy the next one. I love those, but that's not my example. Those are great
too. Yeah,
it makes me happy. And now my kids get all excited when we do it when we go in. We're the first ones in line doing it. But I guess I can use a similar example about just being a student. So Paul Davies is a very well-known theoretical physicist, and he was generous enough with his time to take me on as a postdoc. But before I became his postdoc, he invited me to a workshop at Arizona State University in the Beyond Center, and took a walk with me around campus just to talk about ideas after. And I think there were two things that were completely generous about that. One is Paul's philosophy is always interacting with young people is like, you interact with a mind in the room. It doesn't matter, how well known or whatever. It's like you evaluate the person for the person. So, but he also gave me a book, The Eerie Silence, that he had written, and he wrote in it, "This is how EE gets to ET." Which was an antimerric excess, which I worked on as a PhD student, was the origin of homochirality, all the way up to what the book was about, which was, are we alone in the universe, and is there intelligent life out there? And it was just so much about the questions I wanted to ask, because it's like, it was just everything about, like, just it was just really, really kind.
Like that it's okay to ask these questions.
Yeah.
And you can actually
Yeah, I mean, I
have
think
strong
like a
enough
lot
to
of my
answer them.
career is mostly his encouragement to ask deep questions. Like, he gave me the space to do it in ways that a lot of previous mentors had. I mean, I've had a good experience with mentors, but it was like, go off the deep end, ask the hardest questions. And I think that's the best gift you can give somebody.
What would you, because you're both fascinating minds and I would say, non-standard in the best possible way. Is there advice you can give to young folks how to be non-standard, how to stand out, novelty, how to generate novelty?
That's what I want on my tombstone. I have one.
He generated novelty.
No, how to? It's like
how to?
how still. I just love doing science, and so when I was younger, I was just wanted to. I mean, I'm still not sure I'm a real scientist, right? So I want to try. So my advice for young people is just if you love asking questions, then don't be afraid to ask the question, even if it pisses people off. Because if you piss people off, you're probably asking the right question. What I would say, though, is don't do what I did, which is just piss everyone off. Try and work out how to, I think if other people are challenged by your questions, you will get not only respect, but people will create space for you because you're doing something really new. I really try to create space in my academic career with my team, really try and praise them and push them to do new things. So my advice is try to do new things, get feedback, and the universe will help you.
Excellent.
Because the universe likes novelty.
I think so, right?
This one will keep them around.
Oh my God.
What about you, Sarah? You too like to ask the really out there big questions.
Yeah, because I have a strong passion for them. So I think it goes back to the love. Like, if you're doing the thing you're supposed to be doing, you should really love it. So I always tell people that they should do the thing they're most passionate about. But I think a flip side of that is that's when you become, in some way, like, not to sound cheesy, but like your best version of yourself. So I guess, like, for me, as I become more successful in my career, I feel like I can be more myself as an individual. And so there's this, I've always been following the questions I'm most interested in, which very early on I was discouraged from doing by many people because they thought they were unanswerable questions. And I always just thought, well, if no one's even trying to answer them, of course they're going to be unanswerable. And then that was kind of an odd viewpoint. But the more I found my way in that space, the more I also made a space for myself as a person, because you're basically generating the niche that you want to exist in. And so I think that's part of it, is not just to follow your passion, but also think about, like, who do you want to be and create that.
Yeah. Who am I? Who do you want to be? I mean, yeah, play temporally with it.
Yeah, who am I now? Who do I want to be now? But who do I want to be in the future? They're not decoupled.
Yeah. I always wonder if that's like, if I become something, am I finding myself or am I creating myself?
Yeah.
And I think those are somehow the same kind of
Right.
thing. I do feel often like that I was always meant to be this kind of thing.
Yeah. Same.
But is that created or discovered? I don't know. But basically go towards that direction.
Yeah.
If you were abducted by aliens, Sarah.
Excellent. I'm waiting. They can come find me.
They're on a spaceship. They're and then they somehow figured out the language you speak.
Mm-hmm.
And ask you, what are you? Explain yourself. Not you, Sarah, but the species.
Oh.
What's life on Earth? Like we don't have time. We're busy grad students from another planet.
Oh, I see.
What's interesting about human civilization? What's interesting about you? You specifically too. They could be very kind of personal and kind of pushy. And yeah, how would you
I guess
begin to describe?
okay. I have one. Because obviously I self-identify as a scientist and a physicist, but intrinsically I feel more like an artist. But it's almost like you're an artist that you don't know what you're painting yet. And I guess I feel like that's humanity. Like
Yeah.
in some sense, we're creating something I think is profound and potentially very beautiful, like existence in the universe. But we're just so naive, like not naive. We're just early. We're early. We're young. We don't know what we're doing yet.
Yeah. What's with the nuclear weapons is a big question too. Like, what do you guys?
What are
Why?
we doing with them?
Why this creativity that you talk? It sounds very
Yeah.
nice, but you seem
We're
to be
making things that are
like very destructive, and like the
Mhm.
rockets. What this seems very aggressive.
Yeah, I know. This is my blinders on. I don't know. I mean, it goes back to the whole conversation about suffering. I have a hard time regularizing certain aspects of reality into what I want to envision, and that's obviously problematic. But nuclear power has also given us a lot of good things. So,
So both, that's human nature. Both human beings and the technology we create has the capacity for evil and the capacity
yeah,
for
and we
good.
can't all be good all the time. I mean, there's like this huge misnomer that you need to be liked by everyone universally, and obviously that's like an ideal, but it's physically impossible. You can't get a group of people in the room and have everyone like each other all the time. So I think
That
that
would be
kind of
boring.
tension is actually really important. That we have different aesthetics, different goals, and sometimes conflict comes out of that.
Yeah. Speaking of which, do you, Lee, and Yosha Bach ever say anything nice to each other, or is it always conflict?
We never have conflict. We argue, but I don't think the arguments are bad.
It's love.
I mean, I think the problem I have, not problem. I think
Here we go, and he's not here to defend himself.
no, it's just I don't necessarily understand the. I mean, he's just talking at such a high level.
Yeah.
I'm a dimwit, so I'm like I spend some. So I think a lot of our conflict is not conflict. We actually have a. I think. I mean, I can't speak for Yash. I have a deep appreciation for him. He's brilliant, but I think I'm kind of frustrated, and I'm trying to. He thinks the universe is a computer, and I want to turn the universe into a computer.
Yeah, that's a small disagreement. So how would you defend your life to an alien when you're being abducted? Would you focus on the specifics of your life?
No. I would try to be as random as possible and try and confuse them.
Oh, good, good.
Excellent.
That might be the wiser choice.
The Easter eggs in reality.
No, I mean, if the aliens abducted me, I would try and be as random as possible. I would try and do something that would surprise the hell out of them, which I thought, I mean, it's probably quite risky. They might kill me, but I think that might be funny.
They might want to study you for prolonged periods of time.
My reasoning is if I wanted to stay alive, okay, so if the thing is, if I wasn't going back to Earth and the job was to stay alive, if I could be as surprising as possible, they'd keep me around like a pet, right? Pet Lee on the alien space.
So you'd be okay being a pet?
Well, no, but I mean...
The last human that survives would just be a pet to the alien.
I don't know, but I mean, I think that might be fun because then that I might get some feedback from their curiosity. But yeah.
Let me ask you this question. It given our conversation, has a very different meaning. Not a more profound meaning, perhaps, but would you rather lose all of your old memories or never be able to make new ones?
I would have to lose all my old memories.
Again, it's the novelty.
Mm-hmm.
What about you, Sarah?
I'm the same because I don't think, like, it's about the future experience, right? And in some sense, like you were saying earlier, most of our lived experience is actually in our memories. So if you can't generate new memories, it's like you're not alive anymore.
Mm-hmm. That's it. Yeah.
What comforts you on bad days when you look at human civilization, when you look at your own life? What gives you hope? What makes you feel good about what we're doing, about life at the small scale of you as a human and at the big scale of us as a human civilization, maybe the big scale of the universe?
Children, my kids, but I also mean that in like a grand sense of like, not a grand, but like future minds in some sense. So for me, like the most bleak movie ever, people worry about apocalyptic things like AI, existential risk, and climate change, was Children of Men. The whole premise of the movie was there can be no children born on the entire planet. And youngest person on the planet is like 18 years old or something.
Mm.
Like, can you imagine a world without children? It's harrowing. That's the scariest thing. So I think what gives me hope is always youth and the hope of children and the possibilities of the future they see. And they grow up in a completely different reality than adults do. And I think we have a hard time seeing what their reality actually looks like. But I think most of the time it's super interesting.
Yeah, they have dreams, they have imagination, they have this kind of excitement.
Yeah.
It's so cool. It's so fun to
so
watch.
refreshing.
And yeah, you feel like you're almost getting in the way
Yeah.
of all that imagination. What about you, Lee? What gives you hope?
So when I go back to my 8-year-old self, the thing that I dreamed of as my 8-year-old self was this world in which technology became programmable and there was the internet and I get information and I would expand my consciousness by just getting access to everything that was going on. And this happened in my lifetime. I mean, we really do have that. I mean, okay, there's some bad things, there's TikTok, everyone just, whatever, all the bad things about social media. But I think, I can't quite believe my luck being born now. It's so amazing.
Being able to program reality in some way.
Yeah. And the thing that I really find fascinating about human beings is that just how ingenious they are. I'm, whether it's from my kids, my research group, my peers, other companies, just how ingenious everyone is. And I'm pretty sure humanity has or our causal chain in which humanity is a vital part in the future is going to have a lot of fun. And I'm just, it's just mind blowing just to watch. And, so humans are ingenious and I hope to help them be more ingenious if I can.
Well, what gives me hope, what makes me feel good on bad days is the existence of wild minds like yours, novelty generators, assembly structures that generate novelty and do so beautifully, and then tweet about it. Sara, I really, really enjoyed talking to you. I enjoy following you. I'm a huge fan. Sara, Lee, I hope to talk to you many times in the future, maybe with your Shabak. You're just incredible people. Thank you for everything you do. You're awesome. Thank you for talking today. Really, really appreciate it.
Thanks.
Yeah, brilliant to be here.
Thanks for listening to this conversation with Sara Walker and Lee Cronin. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Arthur C. Clarke. 2 possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. And let me, if I may, add to that by saying that both possibilities, at least to me, are both terrifying and exciting. And keeping these 2 feelings in my heart is a fun way to explore, to wonder, to think, and to live. Always a little bit on the edge of madness. Thank you for listening. I hope to see you next time.